Hello there, and welcome to the Sleepy Science Channel. Tonight, we'll be journeying to the top of the world, to a place of endless ice, dancing lights, and profound stillness, the North Pole, a realm where the sun circles the horizon for months at a time, where the ocean lies hidden beneath thick layers of frozen water, and where the Earth's magnetic forces converge in invisible streams. This is a land of extremes, where temperatures plunge to depths that defy imagination, yet life persists in ways both delicate and remarkable. The North Pole is not a place you can simply visit like any other destination. It is remote, shifting, and constantly changing. The ice beneath your feet would be floating, drifting slowly across the Arctic Ocean. There are no permanent markers here, no flags that remain where they were planted. Everything moves with the currents and the seasons. And yet, this drifting wilderness at the top of our planet holds secrets that have captivated explorers, scientists, and dreamers for centuries. If you enjoy these quiet explorations, I invite you to like and subscribe or share a simple thought down in the comments. It helps others find their way here, too. One sleepy soul at a time. But for now, all you need to do is rest, settle in, and allow the calm of the frozen north to carry you. Let's begin. The North Pole sits atop a frozen ocean, not solid land. When you imagine the North Pole, you might picture a vast continent of ice and snow, similar to Antarctica, but the reality is quite different. The North Pole is located in the middle of the Arctic Ocean, where the sea freezes into thick sheets of ice that float upon the water below. There is no landmass beneath the pole itself, only the deep ocean, dark and cold, hidden under layers of ice that can be several meters thick. This ice is not still. It drifts with ocean currents and winds, moving slowly but constantly. A person standing at the geographic North Pole today would find themselves in a slightly different location tomorrow, carried by the ice as it shifts. Scientists who visit the pole must recalculate their position frequently, because the ice beneath them is always on the move. Unlike the South Pole, which rests on the solid continent of Antarctica, the North Pole is ephemeral, a point in space defined only by coordinates, floating on a restless sea. The Arctic Ocean beneath the ice is surprisingly deep. Beneath the frozen surface at the North Pole lies one of the world's great oceans. The Arctic Ocean may be the smallest of Earth's oceans, but it is far from shallow. In many places, the water plunges to depths of more than 4,000 meters. That is deeper than most mountain peaks are tall. The ocean floor here is a landscape of underwater mountains, ridges, and vast plains, all hidden in perpetual darkness. This deep water remains liquid even as the surface freezes, because salt lowers the freezing point. The ocean circulates slowly, driven by currents that connect it to the Atlantic and Pacific. Within its depths, live creatures adapted to extreme cold and darkness, jellyfish drifting through black water, fish with antifreeze proteins in their blood, and microorganisms that thrive where sunlight never reaches. The ice above may seem like a barrier, but below it lies an entire ecosystem, silent and unseen. The ice at the North Pole is constantly moving and shifting. The Arctic ice cap is not a solid, unmoving sheet. It is a dynamic mosaic of ice flows, some small, others stretching for kilometers, all drifting with the currents. These flows collide, crack, and reform, creating pressure ridges where ice piles up into jagged walls, and leads where open water appears even in the depths of winter. The ice can be smooth in one place and chaotic in another, shaped by forces both above and below. This movement means that the Arctic is always changing. Satellite images show ice swirling in slow motion, opening and closing like breathing. During summer, the ice retreats, shrinking back toward the pole. In winter, it expands outward again. Over the decades, scientists have observed that this cycle is shifting. The ice grows thinner, and the summer retreat extends farther. The Arctic is warming faster than almost anywhere else on Earth, and the ice that has defined the North Pole for millennia is transforming before our eyes. For 6 months of the year, the sun never sets at the North Pole. One of the most remarkable features of the North Pole is its relationship with the sun. Due to the tilt of Earth's axis, the pole experiences 6 months of continuous daylight during summer. From around late March to late September, the sun circles the horizon, never dipping below it. Day and night lose their meaning. There is only an endless procession of light, the sun tracing a slow spiral across the sky. This phenomenon is called the polar day, and it creates a world bathed in perpetual twilight and brightness. The sun never climbs high overhead as it does at the equator. Instead, it hovers low, casting long shadows and painting the ice in soft hues of gold and pink. For anyone standing at the pole during this time, the experience would be surreal. Time seems to blur when the sky never darkens. Sleep cycles become arbitrary. The world feels suspended in a single, stretched moment of luminous calm. Then, for the other 6 months, the sun never rises. As summer fades, the sun begins its descent. Around late September, it touches the horizon and then slips below, not to return for half a year. The North Pole enters a period called the polar night, a time of darkness that lasts until late March. But this darkness is not absolute. Even without the sun, the sky is not entirely black. During the early and late parts of polar night, there is a faint glow on the horizon, a memory of the sun just beyond the edge of the world. As the months deepen, true darkness arrives. The stars appear in their full glory, and the aurora borealis dances across the heavens with no competing light to diminish its brilliance. The moon, when it rises, becomes the primary source of illumination, reflecting off the ice and creating a landscape of silver and shadow. For those who experience polar night, it is a time of profound stillness. The world becomes quieter, the cold deepens, and the sky transforms into a canvas for the universe's most beautiful lights. The temperature at the North Pole can plunge to -50 degrees Celsius. The North Pole is one of the coldest places on Earth, though not quite the coldest. During the depths of winter, temperatures regularly drop to -40 or -50 degrees Celsius. At such temperatures, exposed skin can freeze in minutes. Metal becomes brittle. Rubber shatters like glass. Even the air itself feels sharp and hostile. Each breath a reminder of the extremes you are enduring. Yet, surprisingly, the North Pole is not as cold as the South Pole. Antarctica holds that record, with winter temperatures sometimes reaching -80 or -90 degrees. The difference lies beneath. The North Pole sits above an ocean, which retains some heat even when frozen. Antarctica, by contrast, is a massive landmass covered in ice kilometers thick, with no ocean below to moderate the temperature. Still, the cold at the North Pole is formidable. It is a cold that seeps into everything, that silences sound, and that turns the world into a frozen sculpture. During summer, temperatures at the North Pole hover near freezing. When the sun returns and the polar day begins, the North Pole warms. But warm is a relative term. Summer temperatures typically hover around 0 degrees Celsius, just at the freezing point of water. The ice begins to melt at the edges, creating pools of water on the surface and widening the cracks between flows. But the pole itself rarely warms much beyond freezing. There are no hot summer days here, no warmth that would feel comfortable to human skin. This brief period of relative warmth is critical for the Arctic ecosystem. Seals surface through breathing holes in the ice. Birds arrive to nest on the edges of the ice cap. Algae blooms beneath the ice, feeding tiny creatures that in turn feed fish and whales. The Arctic comes alive in summer, a burst of activity compressed into a few short months before the cold returns. But even in summer, the North Pole remains a place of ice and chill, a reminder that this is the top of the world, where warmth is fleeting and winter is eternal. The geographic North Pole is different from the magnetic North Pole. When most people think of the North Pole, they imagine a single point at the very top of the globe. But in truth, there are multiple North Poles, each defined differently. The geographic North Pole, also called true north, is the point where Earth's axis of rotation meets its surface. This is the point at the center of the Arctic Ocean, the place where all lines of longitude converge. It is a fixed point in space, determined by the planet's spin. The magnetic North Pole, however, is something else entirely. This is the point where Earth's magnetic field lines point vertically downward, the place a compass needle tries to point toward. Unlike the geographic pole, the magnetic pole is not fixed. It wanders, drifting across the Arctic as the molten iron in Earth's core shifts. Over the past century, the magnetic North Pole has moved hundreds of kilometers, migrating from Canada towards Siberia. Scientists track its movement carefully, updating navigation charts and GPS systems to account for the shift. The magnetic North Pole drifts across the Arctic over time. The movement of the magnetic North Pole is not random, but follows patterns driven by changes deep within the Earth. The outer core of our planet is a churning ocean of liquid iron and nickel, and as this metal flows, it generates Earth's magnetic field. Variations in the flow cause the magnetic poles to wander. In recent decades, the magnetic North Pole has been moving faster than usual, traveling at speeds of up to 50 kilometers per year. This drift has practical implications. Navigators, pilots, and ships rely on magnetic compasses, and as the pole moves, navigation systems must be recalibrated. Airports update their runway numbers, which are based on magnetic headings. Scientists study the movement to understand the dynamics of Earth's core. Some wonder if the acceleration of the pole's drift signals an approaching magnetic reversal, an event where the north and south magnetic poles flip. Such reversals have happened many times in Earth's history, though they occur over thousands of years, not overnight. Compasses point toward the magnetic North Pole, not the true North Pole. If you were to stand at the geographic North Pole with a compass in hand, the experience would be disorienting. A compass needle aligns with Earth's magnetic field, pointing toward the magnetic North Pole, which is currently located hundreds of kilometers away from true north. At the geographic pole, where all directions are south, a compass would spin or point in seemingly random directions, confused by the convergence of magnetic field lines. This difference between magnetic and geographic north matters greatly for navigation. Mariners and pilots must account for magnetic declination, the angle between true north and magnetic north, which varies depending on location. In some places, the two are aligned. In others, they diverge by many degrees. Maps include declination information, small adjustments that ensure travelers reach their intended destinations. The North Pole, both geographic and magnetic, is a reminder that Earth is a dynamic planet, its fields and forces constantly shifting beneath our feet. The North Pole has no time zone because all time zones converge there. Time zones are based on lines of longitude, with each zone representing roughly 15 degrees of Earth's rotation. But at the North Pole, all lines of longitude meet at a single point. This creates a curious problem. What time is it at the pole? Technically, all time zones exist there simultaneously. You could step a few meters in any direction and cross into a different time zone. In practice, researchers and explorers at the pole often use Coordinated Universal Time, also known as UTC, to avoid confusion. Others use the time zone of their home country or the base from which they departed. But the question itself highlights the arbitrary nature of timekeeping. Time is a human construct, a way of organizing our experience of the planet's rotation. At the pole, where that rotation is most abstract, time becomes almost meaningless. There is only the slow spin of the Earth, the sun's endless circle, and the drift of ice beneath your feet. Early explorers faced incredible hardships reaching the North Pole. For centuries, the North Pole remained one of the last unreachable places on Earth. Explorers dreamed of being the first to stand at the top of the world, but the journey was fraught with danger. Expeditions set out across the frozen Arctic, hauling sleds over jagged ice, enduring temperatures that froze their breath, and facing the constant threat of leads opening beneath them, plunging men and equipment into the freezing ocean. Ships became trapped in ice, their crews spending years locked in the frozen sea. Men suffered from frostbite, scurvy, and starvation. Some lost their lives, others returned broken by the experience. The ice was an unforgiving opponent, shifting unpredictably, creating barriers where none had existed, and swallowing the unwary. Yet still, they came, driven by ambition, national pride, and the simple human desire to reach the unreachable. Robert Peary claimed to reach the North Pole in 1909. On April 6, 1909, American explorer Robert Peary announced that he and his team had reached the North Pole. After years of attempts, suffering, and setbacks, Peary planted a flag at what he believed was the top of the world. He returned to a hero's welcome, his achievement celebrated around the globe. For decades, his claim was accepted as fact, written into history books and taught to schoolchildren. But doubts lingered. Peary's navigational records were incomplete. His speed over the ice seemed impossibly fast, and some accused him of exaggerating his progress. Another explorer, Frederick Cook, claimed to have reached the pole a year earlier, in 1908, though his claim was also disputed. The controversy has never been fully resolved. Modern analysis suggests that Peary may have come close but likely fell short of the exact pole. Regardless of the truth, his expeditions pushed the boundaries of human endurance and brought the world's attention to the Arctic. The first undisputed visit to the North Pole was by aircraft in 1926. While Peary's claim remains debated, there is no doubt about who first reached the pole by air. On May 9, 1926, Norwegian explorer Roald Amundsen, along with American sponsor Lincoln Ellsworth and Italian pilot Umberto Nobile, flew over the North Pole in the airship Norge. Unlike surface expeditions, their position could be verified with precision using the sun and navigational instruments. The flight marked a turning point. The pole, once a distant dream reachable only through months of suffering, could now be visited in hours. The age of polar exploration by sled and ship gave way to the age of aviation. Over the following decades, aircraft became the primary means of reaching the pole, transforming it from an unreachable point into a destination for scientists, adventurers, and eventually, even tourists. The first confirmed surface expedition to the North Pole occurred in 1968. It was not until 1968 that humans definitively reached the North Pole by traveling over the ice. An American team led by Ralph Plaisted used snowmobiles to cross the frozen Arctic Ocean, reaching the pole on April 19th. Their position was confirmed by air navigation, leaving no doubt about their achievement. A few weeks later, another expedition led by Wally Herbert reached the pole on foot, completing a journey across the Arctic that many consider the last great polar exploration. These expeditions proved that reaching the pole overland was possible, though it remained extraordinarily difficult. The ice was treacherous, the weather brutal, and the logistics immense. Yet they succeeded, adding their names to the short list of those who had stood at the top of the world. Today, with modern technology, reaching the pole is easier, though still challenging. GPS systems provide precise locations. Aircraft can evacuate teams in emergencies, and satellite communication keeps explorers connected to the world. But the ice remains as unforgiving as ever. Nuclear submarines have surfaced at the North Pole beneath the ice. One of the most dramatic visits to the North Pole came from below. On August 3, 1958, the United States Navy submarine, USS Nautilus, became the first vessel to reach the pole by traveling under the Arctic ice. The submarine navigated in darkness, using sonar to avoid ice ridges and maintain depth. When it passed beneath the pole, the crew celebrated quietly, aware they were making history. 2 years later, in 1960, the submarine USS Skate surfaced directly at the North Pole, breaking through the ice. The crew climbed out onto the frozen surface, standing at the top of the world in a scene that seemed almost surreal. Since then, submarines have occasionally visited the pole, demonstrating that the Arctic Ocean, though frozen above, remains navigable below. These underwater journeys are a reminder that the North Pole is not just a point on the ice, but a three-dimensional space, accessible from above, across, and beneath. The North Pole is a site of international scientific research. Today, the North Pole is less a destination for adventurers and more a laboratory for scientists. Research stations drift with the ice, carrying teams of researchers who study climate, oceanography, ice dynamics, and atmospheric chemistry. These stations are temporary, assembled each year and dismantled when the ice begins to break up. Scientists live in tents or small huts, surrounded by instruments that measure everything from ice thickness to wind speed. The data they collect is invaluable. The Arctic is warming faster than any other region on Earth, and understanding why is critical for predicting global climate patterns. Ice cores drilled from the frozen surface reveal atmospheric conditions from thousands of years ago, locked in tiny bubbles of ancient air. Ocean measurements track the flow of currents that influence weather across the Northern Hemisphere. The North Pole, once a symbol of the unknown, is now a key to understanding our planet's future. Icebreakers are essential for reaching the North Pole by sea. Despite the thickness of the Arctic ice, ships can reach the North Pole, but only with the help of icebreakers. These specialized vessels have reinforced hulls and powerful engines designed to smash through ice several meters thick. They push forward relentlessly, breaking a channel that other ships can follow. The largest icebreakers, many operated by Russia, can force their way through ice that would stop any ordinary ship. Reaching the pole by icebreaker is a slow, grinding process. The ship rocks and shudders as it climbs onto the ice, its weight breaking the frozen surface. Progress is measured in kilometers per hour, sometimes less. But eventually, the vessel arrives at the pole, where passengers can step out onto the ice and stand at the top of the world. For those aboard, the journey is an experience unlike any other, a voyage through a landscape of white silence, broken only by the crack and groan of ice yielding to steel. Tourism to the North Pole is rare but possible. In recent decades, a small number of adventurous travelers have visited the North Pole. Icebreaker cruises carry passengers from Russia through the Arctic Ocean, breaking through the ice until they reach 90 degrees north. The journey takes weeks and costs tens of thousands of dollars, making it one of the world's most exclusive travel experiences. Those who make the trip describe a landscape of otherworldly beauty, endless white ice under vast skies, with only the sound of the ship and the wind. Others reach the pole by ski or helicopter, landing on the ice for brief visits before flying out. Some attempt the journey on foot, dragging sleds across the ice in a test of endurance and determination. But all visitors share a common experience: the profound isolation of standing at the top of the world, where every direction is south and the horizon stretches in a perfect circle. It is a place that feels like the edge of the earth, a boundary between the known and the infinite. The ice at the North Pole is shrinking due to climate change. The Arctic is changing. Satellite records show that the extent of sea ice at the North Pole has been declining for decades. Each summer, the ice retreats farther than it did the year before. Each winter, it grows back a little less. The ice that remains is thinner, younger, and more fragile than it was in the past. Old, thick ice that once persisted for years is disappearing, replaced by ice that forms and melts within a single season. This loss has profound implications. The white surface of the ice reflects sunlight, helping to cool the planet. As the ice shrinks, darker ocean water is exposed, absorbing more heat and accelerating warming. This feedback loop is one reason the Arctic is warming twice as fast as the global average. Scientists warn that the North Pole could be ice-free in summer within a few decades, a transformation that would reshape weather patterns, ocean currents, and ecosystems around the world. Some scientists predict ice-free summers at the North Pole by mid-century. Climate models project a future Arctic dramatically different from today. By the middle of this century, possibly sooner, the North Pole may experience summers without ice. The frozen cap that has existed for millennia could melt away entirely during the warmest months, leaving open water at the top of the world. In winter, ice would still form, but it would be thin and seasonal, nothing like the thick, multi-year ice that once defined the region. This shift would have cascading effects. Shipping routes across the Arctic would become navigable, reducing travel times between continents. But the environmental cost would be immense. Polar bears, seals, and other ice-dependent species would face habitat loss. Indigenous communities that rely on the ice for hunting and travel would see their way of life disrupted. The global climate system, which depends on the Arctic's cooling influence, would be altered in ways that are difficult to predict. The loss of ice would also expose new challenges. Open water absorbs more heat, creating stronger storms. Thawing permafrost releases methane, a potent greenhouse gas, further accelerating warming. The transformation of the Arctic is not just a regional issue, but a planetary one, a signal that the Earth's climate is entering uncharted territory. Polar bears are the most iconic animals of the North Pole region. When people imagine the Arctic, they often picture the polar bear, a powerful predator perfectly adapted to life on the ice. These bears are the largest land carnivores on Earth, with males weighing up to 800 kilograms. Their white fur blends with the snow and ice, camouflaging them as they hunt. Beneath the fur, their skin is black, absorbing heat from the sun. Beneath the skin lies a thick layer of blubber that insulates them against the cold. Polar bears spend most of their lives on sea ice, where they hunt seals. They wait by breathing holes in the ice, patient and still, sometimes for hours, until a seal surfaces. Then, with explosive speed, they strike. A single bear can consume enormous amounts of food, storing energy in fat reserves that sustain them through times when hunting is difficult. For polar bears, the ice is not just habitat. It is a hunting platform, a migration route, and the foundation of their existence. As the ice shrinks, polar bears face an uncertain future. With less ice, bears must travel farther to find food. Some swim vast distances, a feat of endurance that exhausts them. Others come ashore, where food is scarce and conflicts with humans increase. Scientists have documented bears losing weight, producing fewer cubs, and struggling to survive. The polar bear has become a symbol of climate change, an emblem of what is being lost as the Arctic warms. Conservation efforts are underway, but the bear's fate is tied to the fate of the ice. If the ice disappears, polar bears may vanish from much of their range, surviving only in the coldest refuges or in zoos. Their story is a reminder that the changes happening at the North Pole are not abstract. They are real, affecting creatures that have lived here for millennia. Arctic foxes thrive in the extreme cold near the North Pole. Smaller, but no less remarkable than the polar bear, the Arctic fox is a master of survival. With thick fur that changes color with the seasons, white in winter and brown or gray in summer, these foxes are superbly adapted to the Arctic environment. Their fur is so dense it insulates them down to -70 degrees Celsius, making them one of the few mammals that can remain active even in the worst Arctic cold. Arctic foxes are opportunistic feeders. They scavenge the remains of polar bear kills, hunt small mammals like lemmings, and raid bird nests during the brief summer. In winter, when food is scarce, they cache surplus food under the snow, a survival strategy that allows them to endure the leanest months. Their small size and low body mass mean they need less food than larger predators, an advantage in an environment where calories are precious. These foxes are also nomadic, traveling vast distances across the ice in search of food. They have been observed hundreds of kilometers from the nearest land, roaming the frozen ocean like tiny wanderers. Their resilience is astonishing, a testament to the adaptability of life even in the harshest places. Ringed seals are the most common seals in the Arctic. Beneath the ice at the North Pole, ringed seals thrive. These small seals are the most abundant marine mammals in the Arctic, perfectly suited to life in the frozen ocean. They maintain breathing holes in the ice, gnawing through the frozen surface with their teeth to create access to the air above. In winter, they excavate lairs in snowdrifts above their breathing holes, hidden spaces where they rest and give birth to their pups. Ringed seals feed on fish and crustaceans, diving deep into the cold water to hunt. Their thick blubber insulates them, and their streamlined bodies make them agile swimmers. They are, in turn, the primary prey of polar bears, which depend on them for survival. The relationship between predator and prey is ancient and balanced, shaped by millennia of evolution. As the ice changes, ringed seals face new challenges. Earlier ice breakup means less time to nurse pups, reducing survival rates. Thinner ice makes it harder to build secure lairs, leaving pups vulnerable to predators and weather. The fate of the ringed seal, like so many Arctic species, is intertwined with the ice. Narwhals are known as the unicorns of the sea. Among the most mysterious creatures of the Arctic is the narwhal, a medium-sized whale known for the long, spiraled tusk that extends from the males. This tusk, actually an elongated tooth, can grow to 3 meters in length and has inspired myths and legends for centuries. Medieval traders sold narwhal tusks as unicorn horns, claiming they had magical properties. Scientists now understand that the tusk is a sensory organ, packed with nerve endings that allow the whale to detect changes in water temperature, salinity, and pressure. Narwhals live in the icy waters near the North Pole, diving deep to hunt fish and squid. They navigate under the ice, surfacing through cracks and leads to breathe. Their ability to survive in such extreme conditions is remarkable, a product of evolution in one of the planet's most demanding environments. Narwhals are social animals, traveling in groups called pods. Their calls echo through the dark water, a series of clicks, whistles, and pulses that help them navigate and communicate. To listen to a narwhal is to hear the voice of the Arctic itself, ancient and strange. Walruses haul out on ice floes to rest. Another iconic Arctic animal is the walrus, a massive pinniped with long ivory tusks and thick, wrinkled skin. Walruses use ice floes as resting platforms, hauling their heavy bodies out of the water to sleep and socialize. These gatherings can number in the hundreds, with walruses packed together in dense groups. Their tusks, which can grow to a meter in length, are used for fighting, establishing dominance, and hauling themselves onto the ice. Walruses feed on the seafloor, diving to depths of up to 100 meters to search for clams, snails, and other invertebrates. They use their sensitive whiskers to detect prey buried in the sediment, then suck the soft bodies from the shells. A single walrus can consume thousands of clams in a day, a testament to their prodigious appetite. As ice diminishes, walruses are forced to haul out on land instead of ice floes. This change creates new dangers. Overcrowding on beaches can lead to stampedes, especially if the animals are startled. Young walruses are sometimes crushed in the chaos. The loss of ice is altering the walrus's way of life, forcing them to adapt to a world that is changing faster than evolution can keep pace. Arctic terns migrate from pole to pole each year. One of the most extraordinary journeys on Earth is undertaken by a small bird. The Arctic tern migrates from the Arctic to the Antarctic and back again each year, a round trip of more than 70,000 kilometers. These birds experience 2 summers, following the sun from one pole to the other and seeing more daylight than any other creature. Arctic terns nest near the North Pole during the Arctic summer, raising their chicks on the brief bounty of insects and fish. When winter approaches, they depart on their epic migration, flying south across the Atlantic, down the coasts of Africa and South America, all the way to the Antarctic. There, they spend the Antarctic summer feeding on the rich waters before making the return journey. This migration is a feat of endurance and navigation. The terns fly vast distances over open ocean, guided by instinct, the sun, and Earth's magnetic field. They are tireless travelers, spending most of their lives in flight, touching down only to breed and rest. To witness an Arctic tern at the North Pole is to see a creature that connects the 2 ends of the Earth, a living thread across the globe. Snowy owls hunt across the Arctic tundra near the pole. The snowy owl is a bird of the far north, ghostly white with piercing yellow eyes. During the Arctic summer, these owls hunt across the tundra near the edges of the ice cap, feeding primarily on lemmings and other small mammals. Unlike most owls, snowy owls are active during the day, an adaptation to the continuous daylight of the polar summer. Their white plumage provides perfect camouflage against the snow. They sit motionless on the ground or atop rocky outcrops, scanning for movement. When prey is spotted, they strike with silent precision, their powerful talons seizing the victim before it can escape. In years when prey is abundant, snowy owls may raise large broods, with up to 10 chicks hatching in a single nest. In winter, some snowy owls migrate south, appearing in Canada, the northern United States, and even Europe. Others remain in the Arctic year-round, enduring the polar night and extreme cold. Their ability to survive in such conditions is remarkable, a testament to their resilience. To see a snowy owl near the North Pole is to witness a creature perfectly suited to its environment, a hunter of the ice and snow. Lichens grow slowly on rocks exposed above the ice. Even in the harsh environment near the North Pole, life finds a way. Lichens, symbiotic organisms composed of fungi and algae, grow on rocks and exposed ground at the edges of the ice. They are among the hardiest life forms on Earth, able to survive extreme cold, intense UV radiation, and long periods without water. Their growth is measured in millimeters per year, a slow accumulation that can create colonies centuries old. Lichens are important pioneers, breaking down rock and creating soil where other plants can eventually take root. They provide food for caribou and other herbivores during winter, when other vegetation is buried under snow. Their colors range from bright orange to pale green to deep black, adding subtle splashes of color to a landscape otherwise dominated by white and gray. To examine a lichen near the North Pole is to look at one of life's simplest and most enduring forms. These organisms ask for almost nothing and persist against all odds, clinging to bare rock in a world of ice. They are a reminder that life's resilience knows few bounds. Mosses carpet the ground in brief summer bursts of green. During the short Arctic summer, mosses bloom across the tundra. These small plants grow in dense mats, covering the ground in soft carpets of green. They absorb water like sponges, creating wet, squishy landscapes that squelch underfoot. Mosses require no roots in the traditional sense. They draw moisture and nutrients directly from the air and rain, thriving in the thin soils of the Arctic. For a few weeks each year, the tundra transforms. The endless white of winter gives way to green, dotted with tiny wildflowers that bloom and set seed in a frantic rush to reproduce before the cold returns. The air hums with insects, and birds arrive to feast on the sudden abundance. Moss plays a crucial role in this ecosystem, stabilizing the soil, retaining moisture, and providing habitat for countless invertebrates. When winter returns, the mosses freeze, their cells entering a state of suspended animation. They can survive being frozen solid and will resume growth when warmth returns. This cycle has repeated for thousands of years, the mosses enduring, persisting, waiting patiently for the brief summer sun. Tiny wildflowers bloom during the Arctic summer. Among the most delicate sights in the Arctic are the wildflowers that bloom during summer. These plants, often no more than a few centimeters tall, produce flowers of surprising beauty, tiny blossoms in shades of purple, yellow, and white. They grow low to the ground, sheltered from the wind, and complete their entire reproductive cycle in just a few weeks. Arctic wildflowers are marvels of adaptation. They can photosynthesize under the low angle of the polar sun, and some even generate heat, melting the snow around them to emerge earlier. Bees and other pollinators visit the flowers, ensuring reproduction before the frost returns. Seeds are produced, scattered, and then lie dormant through the long winter, waiting for the next brief window of growth. These flowers are reminders that beauty exists even in the harshest places. To see a patch of purple saxifrage blooming on the tundra near the North Pole is to witness the triumph of life over adversity, a splash of color in a world of ice. The aurora borealis dances above the North Pole in winter. One of the most breathtaking sights at the North Pole is the aurora borealis, the northern lights. During the polar night, when the sun is absent and the sky is dark, the aurora often appears, draping the heavens in curtains of green, purple, and red light. These lights shimmer and pulse, moving as if alive, shifting forms that seem to dance across the sky. The aurora is created when charged particles from the sun collide with Earth's atmosphere, energizing atoms of oxygen and nitrogen. The magnetic field guides these particles toward the poles, which is why auroras are most commonly seen in Arctic and Antarctic regions. Each color corresponds to a different gas and altitude. Green comes from oxygen at lower altitudes, red from oxygen higher up, and purple from nitrogen. To stand beneath the aurora at the North Pole is to witness one of nature's grandest displays. The lights can fill the entire sky, rippling and waving, bright enough to read by. Indigenous peoples of the Arctic have long told stories about the aurora, seeing in them the spirits of ancestors, animals dancing in the sky, or omens of change. Scientifically understood yet still mysterious in their beauty, the northern lights remain one of the Arctic's most enchanting phenomena. The aurora appears in many colors, from green to red to purple. While green is the most common color of the aurora borealis, the lights can take on a variety of hues. Green auroras result from oxygen atoms about 100 kilometers above the Earth's surface, releasing light as they return to their normal state after being energized by solar particles. This green glow is often the brightest and most visible, painting the sky in luminous waves. Red auroras are rarer and occur at higher altitudes, above 200 kilometers, where oxygen is less dense. The light is dimmer, but when conditions are right, the sky can blush a deep crimson. Purple and blue hues come from nitrogen, adding streaks of color to the green curtains. Sometimes, all these colors appear together, creating a kaleidoscope that shifts and changes moment by moment. The intensity and color of the aurora depend on solar activity. During strong solar storms, the lights become more vivid and extend farther from the poles, sometimes visible as far south as the Mediterranean or northern United States. Each display is unique, an unrepeatable performance written in light across the sky. Solar storms intensify the northern lights. The aurora borealis is linked to the sun's activity. When the sun releases a burst of charged particles in an event called a coronal mass ejection, these particles race toward Earth at speeds of millions of kilometers per hour. When they reach our planet, they interact with the magnetic field, compressing it and funneling particles toward the poles. During these solar storms, the aurora becomes more intense, colors deepen, movements quicken, and the lights can fill the sky from horizon to horizon. Sometimes, the aurora appears as discrete arcs, other times as diffuse glows or rapidly shifting rays. The unpredictability adds to the magic. You can never know exactly when or how the aurora will appear, only that when the sun is active, the chances improve. Scientists monitor solar activity to forecast auroras, giving enthusiasts a chance to prepare. But even with predictions, the aurora remains capricious, a reminder that nature's beauty cannot be commanded, only witnessed with patience and gratitude. Auroras produce faint sounds that few people hear. For centuries, people in the Arctic have reported hearing sounds during auroras, faint crackling or whooshing noises that seem to accompany the lights. Scientists long dismissed these reports, reasoning that auroras occur too high in the atmosphere, around 100 kilometers up, for sound to travel to the ground. But recent research suggests the sounds may be real. The theory is that electromagnetic changes associated with the aurora create electrical discharges closer to the ground, perhaps in the layer of air near the surface. These discharges produce faint sounds, audible only in extremely quiet environments. Recordings have captured crackling and popping noises during auroral displays, though the phenomenon remains rare and difficult to study. Whether real or imagined, the idea of the aurora making sound adds to its mystique. To stand in the Arctic silence, watching the lights and hearing faint whispers from the sky, is to feel connected to something vast and ancient, a conversation between the Earth and the cosmos. Indigenous peoples have lived near the North Pole for thousands of years. Long before explorers from southern lands ventured north, people lived in the Arctic. The Inuit, Sami, Chukchi, and other indigenous groups developed cultures perfectly adapted to the extreme environment. They built homes from ice and snow, hunted seals and whales, and traveled vast distances across frozen landscapes using sleds and kayaks. These peoples understood the Arctic intimately. They read the ice, predicting where it was safe to travel and where it was not. They navigated by the stars, the sun, and subtle features in the landscape. They created clothing from animal skins, layered and stitched to provide maximum insulation. They survived and thrived in a place that seemed uninhabitable to outsiders. Their knowledge was passed down through generations, encoded in stories, songs, and practical skills. Today, many indigenous communities continue to live in the Arctic, though modern influences have changed their way of life. Climate change poses new challenges, altering the ice and the animals they depend on. Yet their connection to the land remains deep, a bond shaped by millennia of living at the edge of the world. The Inuit use traditional knowledge to navigate the Arctic ice. Inuit hunters possess an encyclopedic knowledge of the ice. They can identify different types of ice by appearance and sound, knowing which is safe to walk on and which is dangerously thin. They understand how currents and winds shape ice formations, and they can predict weather changes by observing the sky, clouds, and animal behavior. This knowledge is not written in books but taught through experience and observation. Elders pass it to younger generations, taking them onto the ice and teaching them to read the subtle signs. A crack in the ice, the color of the water, the direction of the wind, all these details matter. Mistakes can be fatal, so the learning is rigorous and continuous. Modern technology, including GPS and satellite imagery, provides new tools, but traditional knowledge remains invaluable. Satellites cannot tell you whether ice will hold your weight or whether a storm is approaching faster than predicted. The Inuit have learned to combine old and new, blending ancestral wisdom with modern techniques to navigate a changing Arctic. Igloos provided shelter from the Arctic cold. One of the most iconic symbols of the Arctic is the igloo, a dome-shaped shelter built from blocks of compacted snow. Igloos are remarkable feats of engineering. The dome shape distributes weight evenly, making the structure strong despite being built from snow. The blocks are cut from dense, wind-packed snow and stacked in a spiral, leaning inward until they meet at the top. Inside, the temperature can be significantly warmer than outside, sometimes reaching above freezing, even when the exterior temperature is -40 degrees. Body heat and small oil lamps provide warmth, and the snow acts as insulation, trapping heat inside. Ventilation holes prevent the buildup of carbon dioxide, and the low entrance tunnel traps cold air below the living area, creating a natural temperature gradient. Igloos were traditionally built as temporary shelters during hunting trips, though some were larger and used for extended stays. Today, they are less common, as modern materials and buildings have largely replaced them. But the igloo remains a symbol of ingenuity, a reminder that with knowledge and skill, humans can create comfort even in the most extreme environments. Sled dogs were essential for Arctic transportation. For centuries, sled dogs were the primary means of transportation across the Arctic. Teams of dogs, bred for strength, endurance, and thick fur, pulled sleds loaded with supplies, hunters, and equipment across vast distances. These dogs could navigate in blizzards, find their way home in whiteout conditions, and work tirelessly day after day. The relationship between musher and dogs was one of mutual dependence. The musher cared for the dogs, feeding them, checking their paws for ice and injury, and resting them when needed. The dogs, in turn, provided transportation, companionship, and sometimes even warmth, their bodies used to keep the musher from freezing during the coldest nights. Different breeds were developed for different regions. The Siberian Husky, the Alaskan Malamute, and the Greenland dog are all descendants of ancient Arctic breeds. Today, snowmobiles have largely replaced sled dogs for practical transportation, but dog sledding remains an important cultural tradition. Races like the Iditarod celebrate the endurance and spirit of these remarkable animals. The midnight sun creates continuous daylight in summer. During the Arctic summer, the sun circles the horizon without setting, a phenomenon called the midnight sun. For those experiencing it for the first time, the effect is disorienting. Clocks become meaningless when the sky never darkens. Sleep patterns shift. The world feels suspended in a single, endless day. Wildlife takes advantage of the continuous light. Birds hunt and feed around the clock. Plants photosynthesize without pause, racing to grow and reproduce before winter returns. For humans, the midnight sun can be both exhilarating and exhausting. The constant light energizes some, while others struggle to sleep without darkness. The midnight sun has inspired myths and art across cultures. In Scandinavia, it is celebrated with festivals and gatherings. In the Arctic, it marks the brief window when travel and hunting are easiest, when the ice softens and the tundra blooms. To experience the midnight sun is to step outside the normal rhythms of day and night, into a world where time seems to hold its breath. The polar night brings months of darkness. Just as summer brings continuous light, winter brings continuous darkness. For months, the sun remains below the horizon, and the world enters a state of perpetual twilight and night. This is the polar night, a time when the stars shine without interruption, and the moon becomes the primary source of illumination. The darkness is profound. Without artificial light, the world becomes a landscape of shadows and subtle contrasts. The ice glows faintly under the moon, and the aurora borealis paints the sky in colors invisible during the bright summer. For those who live through it, the polar night is a time of introspection and quiet, a season when life slows and the outside world seems very far away. Yet even in the deepest darkness, there is beauty. The stars are more brilliant than anywhere else, undimmed by light pollution or the sun's glare. Constellations wheel overhead, and the Milky Way stretches across the sky like a river of light. The polar night, though challenging, offers a window into the heavens that few places on Earth can match. The sun appears to spiral upward and downward at the poles. At the North Pole, the sun does not rise and set in the familiar way it does elsewhere. Instead, it spirals. As spring approaches, the sun touches the horizon and begins to circle around it, rising slightly higher with each pass. Over the course of days, it spirals upward until it reaches its highest point in the sky, still low compared to tropical latitudes, but above the horizon nonetheless. For 6 months, it circles without setting, gradually descending in a spiral until, in autumn, it touches the horizon again and slips below. The spiral continues downward, each pass bringing it lower, until it disappears entirely and the polar night begins. This spiral motion is a direct consequence of Earth's axial tilt and rotation, and it creates a sense of time that is circular rather than linear. To watch the sun spiral at the pole is to see the mechanics of the solar system laid bare. The elegant dance of a planet spinning on a tilted axis as it orbits its star. It is both strange and beautiful, a reminder that the familiar rhythms of day and night are not universal, but dependent on where you stand. Ice crystals create halos and sundogs in the polar sky. The Arctic air is often filled with tiny ice crystals, suspended in the cold atmosphere. When sunlight passes through these crystals, it refracts and reflects, creating optical phenomena of breathtaking beauty. One of the most common is the halo, a ring of light encircling the sun or moon. The halo appears at a precise angle, 22 degrees from the light source, a product of the hexagonal shape of ice crystals. Sundogs, also called parhelia, are bright spots of light that appear on either side of the sun, often accompanied by a halo. They occur when ice crystals are aligned horizontally, refracting sunlight toward the observer. Sundogs can be intensely bright, sometimes rivaling the sun itself, and they often display vivid colors, reds on the inside and blues on the outside. These phenomena are common in the Arctic, where ice crystals are abundant. To see a sundog or halo is to witness the intersection of light and ice, simple physics creating beauty. Ancient peoples often interpreted these lights as omens, signs from the sky. Today, we understand their origins, but the sight remains enchanting, a gift from the cold air and the sun. Light pillars appear as columns of light rising from the horizon. Another striking optical phenomenon in the Arctic is the light pillar, a vertical beam of light that appears to extend upward or downward from the sun, moon, or even artificial lights. Light pillars are created when light reflects off flat ice crystals falling through the air. The crystals act like tiny mirrors, bouncing light toward the observer and creating the illusion of a glowing column. Light pillars are most often seen during cold, calm evenings when ice crystals are suspended in the air near the ground. They can appear in shades of white, gold, or even pink, depending on the light source. When multiple pillars appear together, the effect is otherworldly, as if beams of light are reaching from the earth to the heavens. For those who witness them, light pillars are a reminder of the Arctic's quiet magic. The phenomena require specific conditions: cold, calm air, and ice crystals. But when they align, the result is a display of light that feels almost supernatural. Diamond dust glitters in the air on the coldest days. On the coldest, calmest days in the Arctic, the air itself seems to sparkle. This phenomenon is called diamond dust, and it occurs when moisture in the air freezes into tiny ice crystals that remain suspended, catching the light and glittering like diamonds. The effect is subtle, a faint shimmer in the air, but unmistakable once you notice it. Diamond dust is most common when temperatures drop below -30 degrees Celsius. The crystals are so small they can stay aloft for long periods, slowly drifting down. When sunlight or moonlight strikes them, the air seems to glow softly, as if filled with a million tiny stars. The phenomenon is silent and still, adding to the surreal quality of the scene. To walk through diamond dust is to move through a world transformed. The air feels alive with light, each breath visible as vapor, each step crunching on the frozen ground. It is one of the Arctic's quieter marvels, easy to miss but unforgettable once experienced. Frost flowers bloom on new ice in autumn. When the Arctic Ocean begins to freeze in autumn, a delicate phenomenon occurs. Frost flowers, intricate structures of ice crystals, bloom on the surface of newly formed sea ice. These formations look like delicate flowers or feathers, growing several centimeters tall. They form when moisture from the relatively warm ocean evaporates into the extremely cold air above, instantly freezing into crystalline structures. Frost flowers are fragile, collapsing at the slightest touch or when the wind picks up. They last only a short time, usually just a few hours or days before they are destroyed or buried by snow. But while they exist, they create a landscape of astonishing beauty, the ice covered in what looks like a garden of frozen blossoms. Scientists study frost flowers because they concentrate salt and other chemicals from the seawater, affecting atmospheric chemistry. But for observers, they are simply beautiful. a reminder that even in the harsh Arctic, nature finds ways to create moments of unexpected elegance. Pancake ice forms in rough Arctic seas. Not all sea ice forms in smooth sheets. In rough waters, where waves churn the surface, ice forms in a unique way. Small disks of ice, called pancake ice, develop as slush, and ice crystals collide and freeze together. The constant motion of the waves rounds the edges and causes the disks to bump into one another, creating raised rims like the edges of a pancake. Pancake ice can range in size from a few centimeters to several meters across. When conditions are right, entire fields of pancake ice cover the ocean, creating a surreal landscape of floating disks jostling against each other. As the ice thickens and the ocean calms, the pancakes freeze together, forming larger sheets of ice. To witness pancake ice forming is to see the ocean in transition, caught between liquid and solid, movement and stillness. It is a reminder that ice formation is not a simple process, but a dynamic one, shaped by temperature, wind, and waves. Pressure ridges create jagged walls of ice. As sea ice drifts and collides, enormous forces are unleashed. When two ice floes are pushed together by wind or currents, the ice buckles and fractures, piling up into jagged walls called pressure ridges. These ridges can tower several meters high, creating barriers that are difficult to cross. The ice in a pressure ridge is jumbled and chaotic, blocks and slabs tilted at odd angles, frozen in place by the cold. Pressure ridges are hazards for travelers. Crossing them requires careful navigation, climbing over blocks, and avoiding gaps where the ice is unstable. For ships, pressure ridges can be impassable obstacles, even for powerful icebreakers. Yet they are also beautiful, sculptures created by the immense power of moving ice. In the Arctic, pressure ridges are a constant feature, forming and reforming as the ice shifts. They are reminders that the frozen ocean is not static but alive, constantly being reshaped by forces both seen and unseen. Leads are cracks in the ice, revealing open water. Just as ice can pile up, it can also pull apart. Leads are cracks in the sea ice where the frozen surface splits, revealing the dark ocean beneath. Leads can range from narrow cracks a few centimeters wide to vast openings stretching for kilometers. They form when ice is pulled apart by currents, winds, or the rotation of the Earth. Leads are important for Arctic wildlife. Seals use them as access points to the ocean, surfacing to breathe and hunt. Polar bears patrol leads, waiting for seals to appear. Birds dive into the open water to catch fish. For researchers and travelers, leads are hazards. They can open suddenly, cutting off routes and stranding people on drifting ice floes. In the shifting landscape of the Arctic ice, leads are a reminder that nothing is permanent. What is solid one day may be open water the next, the ice constantly breaking and reforming in an endless cycle. The North Pole has been visited by nuclear-powered icebreakers. Russia operates a fleet of nuclear-powered icebreakers, the most powerful ice-breaking vessels in the world. These ships can force their way through ice several meters thick, reaching the North Pole even in the depths of winter. Their nuclear reactors provide virtually unlimited power, allowing them to operate for months without refueling. The journey to the pole aboard a nuclear icebreaker is an experience of raw power. The ship climbs onto the ice, using its weight to break through, then surges forward. The sound is immense, a grinding, cracking roar as the ice yields to steel. Progress is slow, but relentless. Eventually, the ship reaches 90 degrees north, where passengers can step out onto the ice at the top of the world. These icebreakers are not just for tourism. They also support scientific research, supply remote Arctic stations, and keep shipping lanes open. Their ability to reach the pole year-round has made the Arctic more accessible than ever before, though the journeys remain expensive and rare. Some icebreakers can break ice over 2 meters thick. The thickest Arctic ice can defeat all but the strongest ships. The most powerful icebreakers, like Russia's Arktika-class vessels, can break through ice more than 2 meters thick, and in some cases, up to 3 meters. They achieve this through a combination of brute force and clever design. The bow is sloped so the ship rides up onto the ice, using its weight to crack through. The hull is reinforced with thick steel, and the engines generate tens of thousands of horsepower. Breaking through thick ice is slow work. The ship may advance only a few hundred meters per hour in the heaviest ice. But the ability to do so opens regions that would otherwise be inaccessible, allowing supplies to reach remote communities and scientists to study the Arctic year-round. For passengers aboard, the experience is visceral. The ship shudders and groans, ice screeching along the hull. Looking over the side, you see ice cracking and tumbling, blocks the size of cars tossed aside by the ship's passage. It is a demonstration of human engineering conquering one of nature's most formidable barriers. Arctic sea ice extent varies seasonally. The amount of ice covering the Arctic Ocean changes dramatically with the seasons. In winter, the ice expands, covering approximately 15 million square kilometers. In summer, it retreats to about 5 million square kilometers, less than half its winter extent. This seasonal cycle has occurred for millennia, driven by the sun's angle and the length of days. Satellites monitor this cycle closely, providing daily measurements of ice extent. Scientists use this data to track long-term trends. The seasonal cycle continues, but the overall trend is concerning. Both the winter maximum and summer minimum extents are shrinking, indicating that the Arctic is losing ice year after year. This variability matters for weather, ocean currents, and wildlife. The ice reflects sunlight, helping to cool the planet. When it melts, darker ocean water absorbs more heat, accelerating warming. The cycle of growth and retreat is natural, but the accelerating loss of ice is not, and its consequences are global. Multi-year ice is thicker and more stable than first-year ice. Not all Arctic ice is created equal. First-year ice, which forms in autumn and melts the following summer, is relatively thin and fragile, typically 1 to 2 meters thick. Multi-year ice, which survives at least one summer melt season, is much thicker and stronger, often 3 to 4 meters or more. This ice has been compressed and frozen repeatedly, making it denser and more resistant to melting. Multi-year ice is important for the Arctic ecosystem. It provides stable platforms for seals to rest and polar bears to hunt. Its thickness means it melts more slowly, helping to keep the Arctic cooler. But multi-year ice is disappearing. Satellite records show that the proportion of old ice in the Arctic has declined dramatically over recent decades, replaced by thinner, more fragile first-year ice. The loss of multi-year ice is one of the clearest signals of Arctic change. It means the ice cap is becoming less resilient, more vulnerable to warm summers and storms. What took years to build can now melt in a single season, a transformation that reshapes the entire region. The Arctic Ocean is the smallest and shallowest ocean. While the Arctic Ocean covers a significant area, about 14 million square kilometers, it is the smallest of Earth's 5 oceans. It is also the shallowest, with an average depth of around 1,000 meters, much less than the Atlantic or Pacific. In some regions, such as the continental shelves, the water is only a few hundred meters deep. This relative shallowness influences the ocean's behavior. It freezes more easily than deeper oceans, and it is more affected by freshwater input from rivers. The shallow shelves are biologically productive, supporting rich ecosystems of fish, invertebrates, and marine mammals. But the small size and shallow depth also mean the Arctic Ocean is more sensitive to change. Warming water, melting ice, and shifting currents have profound effects. Despite its size, the Arctic Ocean plays a crucial role in the global climate system. It acts as a refrigerator, cooling the atmosphere and oceans. Its ice cap reflects sunlight, helping to regulate temperatures worldwide. To understand the Arctic Ocean is to understand a key component of Earth's climate machinery. The Lomonosov Ridge is an underwater mountain range beneath the pole. Beneath the ice at the North Pole lies a hidden mountain range. The Lomonosov Ridge is an underwater feature that stretches for more than 1,800 kilometers across the Arctic Ocean, from near Greenland to Siberia. It rises several kilometers above the surrounding seafloor, though it remains thousands of meters below the surface. The ridge was discovered in the 1940s and is believed to be a fragment of continental crust that rifted away from the Eurasian landmass millions of years ago. It divides the Arctic Ocean into two major basins, the Amerindian and the Eurasian. The ridge has become significant in modern geopolitics, as nations bordering the Arctic argue over territorial claims and access to resources. Exploring the Lomonosov Ridge requires specialized equipment. Submarines and underwater robots have mapped its contours, revealing a landscape of peaks, valleys, and sediment layers. To know that mountain ranges exist beneath the ice, hidden in darkness, is to realize how much of the Earth remains unexplored, even in regions we think we know. Methane is trapped beneath Arctic permafrost and ice. Beneath the Arctic tundra and the seabed lies a vast reservoir of methane, a potent greenhouse gas. This methane is trapped in frozen ground called permafrost and in ice-like structures called methane hydrates. For thousands of years, the cold has kept this methane locked away, preventing it from entering the atmosphere. But as the Arctic warms, the permafrost thaws, and the methane begins to escape. Scientists have detected plumes of methane bubbling up from the seafloor and seeping from thawing tundra. If large amounts of methane are released, it could accelerate warming dramatically, creating a feedback loop where warming causes more methane release, which causes more warming. The potential release of Arctic methane is one of the most concerning aspects of climate change. It represents a tipping point, a threshold beyond which warming could become self-sustaining. Monitoring methane emissions in the Arctic is a priority for scientists working to understand the future of the planet's climate. Permafrost is ground that remains frozen year-round. Permafrost is soil, rock, or sediment that remains frozen for at least 2 consecutive years. In the Arctic, permafrost can extend hundreds of meters deep, a legacy of ice ages past. The surface may thaw during summer, creating a thin, active layer where plants grow. But below, the ground remains frozen solid, a barrier of ice and rock. Permafrost holds the landscape together. It stabilizes hillsides, supports buildings, and preserves organic material that would otherwise decompose. But when it thaws, the consequences are dramatic. The ground subsides, creating sinkholes and collapsing structures. Roads buckle, buildings tilt and crack. Entire forests can lean at odd angles, creating what is known as drunken forests. Thawing permafrost also releases carbon. Frozen organic material, preserved for millennia, begins to decompose when it thaws, releasing carbon dioxide and methane into the atmosphere. This adds to greenhouse gas concentrations, accelerating warming. The thawing of permafrost is one of the most visible and troubling signs of Arctic change. Ancient creatures are sometimes preserved in Arctic ice. The Arctic ice and permafrost act as a freezer, preserving organic material for thousands of years. Occasionally, when ice melts or permafrost thaws, the remains of ancient creatures are revealed. Woolly mammoths, extinct for thousands of years, have been found with flesh, fur, and even stomach contents intact. Prehistoric wolves, bison, and horses have emerged from the ice, offering scientists a window into the distant past. These discoveries are scientifically invaluable. DNA can be extracted, allowing researchers to study the genetics of extinct species. Tissues reveal information about diet, disease, and environment. Some scientists have even proposed using preserved genetic material to clone extinct animals, though such efforts remain highly controversial and technically challenging. For the public, these finds capture the imagination. To see a creature that walked the earth tens of thousands of years ago, perfectly preserved in ice, is to feel the weight of deep time. The Arctic holds secrets beneath its surface, stories frozen in place, waiting to be uncovered. Woolly mammoths once roamed the Arctic tundra. Long before the ice sheets of the last ice age retreated, the Arctic was home to woolly mammoths. These massive herbivores, standing up to 4 meters tall and weighing several tons, were perfectly adapted to the cold. They had thick fur, small ears to minimize heat loss, and a layer of fat for insulation. They used their long, curved tusks to sweep snow aside and reach the vegetation beneath. Mammoths lived in herds, migrating across the tundra in search of food. They fed on grasses, shrubs, and other plants, shaping the landscape through their grazing. When the climate changed at the end of the Ice Age, mammoths declined, unable to adapt to the warming world and the expansion of forests. The last mammoths survived on a remote Arctic island until about 4,000 years ago, a tiny population that eventually disappeared. Today, their remains emerge from the permafrost, tusks, bones, and sometimes entire carcasses. They are reminders that the Arctic has not always looked as it does now, that the ice-covered wilderness of today was once a grassland teeming with life. The Arctic was once much warmer, millions of years ago. If you could travel back in time 50 million years, the Arctic would be unrecognizable. During the Eocene epoch, the North Pole region was warm and lush, covered in forests of redwoods, ferns, and palms. Alligators swam in rivers, and the climate was more like modern-day Florida than the frozen wilderness of today. This ancient warmth was driven by high levels of carbon dioxide in the atmosphere, the result of volcanic activity and other natural processes. The polar regions were ice-free, and global sea levels were much higher. Fossils from this era, found in Arctic sediments, reveal a world profoundly different from the present, a reminder that Earth's climate has varied dramatically over geological time. The transition to the icy Arctic we know today began around 34 million years ago, when cooling temperatures allowed ice sheets to form. The process accelerated during the ice ages of the past 2 million years, sculpting the Arctic into the frozen realm it is now. But the ancient past reminds us that the Arctic has not always been cold, and that climate is never static. Ice cores reveal ancient climate records. One of the most important tools for understanding past climate is the ice core. Scientists drill deep into the ice cap, extracting long cylinders of ice that preserve a record of snowfall, atmospheric composition, and temperature stretching back hundreds of thousands of years. Each layer of ice represents a year of accumulation. Like the rings of a tree, trapped within the ice are tiny bubbles of ancient air, preserved exactly as they were when the snow fell. By analyzing these bubbles, scientists can measure past levels of carbon dioxide, methane, and other gases, revealing how the atmosphere has changed over time. Dust, pollen, and volcanic ash in the ice provide additional clues about past environments and events. Ice cores from the Arctic have revealed cycles of ice ages and warm periods driven by changes in Earth's orbit. They show that current levels of greenhouse gases are higher than at any time in the past 800,000 years. Ice cores are time machines, allowing us to peer into the deep past and understand the forces shaping our planet's climate. Bubbles in ice cores contain air from thousands of years ago. Each tiny bubble trapped in an ice core is a capsule of the past. When snow falls on the ice cap, air is trapped between the flakes. As the snow is buried and compressed into ice, the air is sealed into bubbles. These bubbles can remain intact for hundreds of thousands of years, preserving samples of the atmosphere exactly as it was. Analyzing these bubbles is painstaking work. Scientists must carefully extract the ice without contamination, then crush or melt it to release the air. Instruments measure the concentrations of gases, revealing past atmospheric conditions. The data shows that carbon dioxide and methane levels have risen and fallen in cycles, closely linked to ice ages and warm periods. Today's greenhouse gas levels are far higher than any seen in the ice core record, a clear signal that human activity is altering the atmosphere in unprecedented ways. The bubbles in Arctic ice are messengers from the past, warning us of the changes we are causing. The North Pole is a site of international cooperation. Despite political tensions elsewhere, the Arctic has largely remained a zone of cooperation. The Arctic Council, established in 1996, brings together the 8 Arctic nations: Canada, Denmark, including Greenland, Finland, Iceland, Norway, Russia, Sweden, and the United States, to address shared challenges. Indigenous communities are also represented, ensuring their voices are heard. The Council focuses on environmental protection, sustainable development, and scientific research. It has facilitated agreements on search and rescue, oil spill response, and fisheries management. Scientists from different nations collaborate on research, sharing data and resources to better understand the Arctic and its changes. This cooperation is vital. The Arctic does not respect borders. Melting ice, shifting wildlife populations, and changing weather patterns affect all nations, not just those with Arctic territory. The North Pole, a place with no permanent human presence, serves as a reminder that some challenges are global and require collective action. The Arctic is rich in natural resources. Beneath the ice and the seabed, the Arctic holds vast reserves of oil, natural gas, and minerals. Estimates suggest that a significant portion of the world's undiscovered oil and gas lies within the Arctic Circle. As the ice retreats, these resources become more accessible, sparking interest from energy companies and nations seeking to secure future supplies. Mining for minerals such as rare earth elements, gold, and diamonds is also increasing. These resources are valuable, but extracting them in the harsh Arctic environment is expensive and risky. Spills, accidents, and environmental damage are major concerns, particularly in a region already stressed by climate change. The tension between resource extraction and environmental protection is one of the defining issues of the modern Arctic. The resources are there, and economic pressures drive their development. But the costs, both environmental and cultural, are high. The North Pole region stands at the center of this debate, a place of pristine wilderness threatened by the demands of a growing world. Oil and gas reserves beneath the Arctic are highly sought after. The lure of Arctic oil and gas is strong. Companies and governments see potential for energy security and economic gain. Advances in drilling technology have made it possible to operate in ice-covered waters, and the retreating ice opens new areas for exploration. But the risks are immense. An oil spill in the Arctic would be catastrophic. Cold temperatures slow the breakdown of oil, and ice makes cleanup efforts nearly impossible. Wildlife, already stressed by a changing environment, would face additional threats. Indigenous communities that depend on the ocean for food and livelihood would see their resources contaminated. Environmental groups and many scientists argue that the Arctic should be off-limits to oil and gas development, preserved as a refuge for wildlife and a stabilizing force for the global climate. The debate is ongoing, balancing immediate economic interests against long-term environmental costs. The outcome will shape the future of the North Pole and the Arctic as a whole. Shipping routes through the Arctic are opening as ice melts. For centuries, explorers dreamed of a northern sea route connecting Europe and Asia, a passage that would shorten voyages by thousands of kilometers. The ice made such routes impassable, but as the Arctic warms and ice retreats, these routes are becoming viable. The northern sea route along Russia's coast and the Northwest Passage through the Canadian Arctic are now navigable for part of the year. Shipping through the Arctic offers economic advantages. Less fuel is needed, transit times are shorter, and congested routes through the Suez or Panama canals can be avoided. But the routes also present challenges. Ice, even in summer, remains a hazard. Weather is unpredictable. Infrastructure like ports and rescue facilities is limited. There are also environmental and political concerns. Shipping brings pollution, the risk of oil spills, and disturbances to wildlife. The opening of Arctic routes raises questions about sovereignty and control. As traffic increases, the Arctic is becoming a new frontier, a region where economic opportunity and environmental fragility collide. The Northwest Passage has been sought by explorers for centuries. The Northwest Passage, a sea route through the Canadian Arctic archipelago, has fascinated explorers since the 1500s. Early expeditions sought a shortcut to Asia, believing a passage through the ice would open trade and bring riches. Many tried and failed. Ships became trapped in ice, crews perished, and entire expeditions vanished. The most famous tragedy was the Franklin expedition of 1845. Sir John Franklin and his crew set out with 2 ships, Erebus and Terror. Well-equipped and confident, they were never seen again. Search parties found evidence of their fate. Ships crushed by ice, crews abandoned, desperate attempts to walk to safety. The mystery of Franklin's fate haunted the public for decades and inspired numerous rescue missions. It was not until the early 20th century that the Northwest Passage was successfully navigated by Roald Amundsen, who spent 3 years carefully working his way through. Today, with less ice, the passage can sometimes be traversed in a single summer season. What once took years and cost lives is now within reach, though the passage remains challenging and remote. The Northeast Passage offers a route along Russia's coast. The Northeast Passage, also called the Northern Sea Route, runs along the northern coast of Russia from the Atlantic to the Pacific. Like the Northwest Passage, it was long sought as a shortcut, but remained blocked by ice. Russian and Soviet explorers and icebreakers worked for decades to map and navigate the route, establishing ports and support stations along the way. Today, the Northern Sea Route is the more developed of the 2 Arctic passages. Russia promotes it as an alternative to southern routes, and traffic has been increasing. Tankers carry oil and gas, cargo ships move goods, and icebreakers keep the route open during the navigable season. But the route is only fully open for a few months each year, and ice conditions vary. The development of the Northeast Passage is changing the geopolitics of the Arctic. It offers economic opportunities, but also raises questions about environmental impact, sovereignty, and the future of a region in rapid transition. The North Pole sits at the heart of these changes, a symbol of the Arctic's transformation. Polar research stations drift with the ice. Scientists studying the North Pole region often work from temporary stations established on the ice itself. These stations, built on thick ice floes, drift with the currents, sometimes hundreds of kilometers, over the course of a year. Researchers live in insulated tents or small buildings, enduring months of isolation and extreme cold to collect data. These drifting stations have a long history. The Soviet Union pioneered the concept, establishing North Pole stations beginning in the 1930s. Teams would be dropped onto the ice by aircraft, along with supplies and equipment, and would remain for months or even a year. The stations drifted across the Arctic, collecting weather data, ocean measurements, and ice observations. Today, international teams continue this tradition. The data they collect is vital for understanding the Arctic system, how the ice moves, how the ocean circulates, and how the atmosphere responds to changes. Life on a drifting station is demanding, but for those who endure it, the rewards are the chance to study one of Earth's most remote and changing environments firsthand. The Mosay expedition was the largest Arctic research mission ever. In 2019, the German icebreaker Polarstern embarked on the Multidisciplinary Drifting Observatory for the Study of Arctic Climate, or MOSE, the most ambitious Arctic research project ever undertaken. The ship deliberately allowed itself to be frozen into the ice near the North Pole, then drifted with the ice for a full year, carrying a team of hundreds of scientists from around the world. The goal was to study the Arctic in unprecedented detail, measuring everything from ice thickness to ocean chemistry to atmospheric conditions. Researchers endured polar night, extreme cold, and the constant threat of ice movements that could crush the ship. They collected vast amounts of data, much of which is still being analyzed. Mosaic represents a new era of Arctic research, large-scale, international, and focused on understanding the system as a whole. The mission highlighted how much remains unknown about the Arctic and how urgent the need is to understand the changes underway. The data from Mosaic will inform climate models and policy decisions for years to come. Polar bears sometimes visit research stations. Life on an Arctic research station comes with unique challenges, and one of them is polar bears. These apex predators are curious and hungry, and they sometimes approach stations in search of food. Researchers must take precautions, establishing perimeters, using tripwires and alarms, and keeping watch for bears. Encountering a polar bear at close range is both thrilling and dangerous. The bears are powerful and unpredictable. They can appear suddenly, emerging from the ice with little warning. Most encounters end without incident, the bear losing interest and moving on. But the presence of bears is a constant reminder that the Arctic belongs to them, and humans are visitors in their domain. For researchers, seeing a polar bear is often a highlight of their time in the Arctic. It is a connection to the wild, a glimpse of one of the planet's most magnificent creatures in its natural habitat. But it is also a reminder of the fragility of that habitat and the need to protect it. The midnight sun affects human circadian rhythms. Humans are adapted to a cycle of day and night, and the continuous daylight of the Arctic summer can disrupt this rhythm. Circadian rhythms, the internal biological clocks that regulate sleep, alertness, and other functions, rely on cues from light and darkness. When the sun never sets, these cues disappear, and sleep patterns can become irregular. Some people adjust easily to the midnight sun, finding they need less sleep or feel more energized. Others struggle, experiencing insomnia, fatigue, and mood changes. Blackout curtains and strict sleep schedules can help, but the lack of natural darkness remains a challenge. For those unaccustomed to it, the constant light can feel disorienting, blurring the distinction between one day and the next. The polar night presents the opposite challenge. Continuous darkness can lead to seasonal affective disorder, a type of depression linked to lack of sunlight. Light therapy, artificial lights that mimic daylight, can help, But the long, dark winter remains difficult for many. The extremes of light and dark at the North Pole are among the most unique aspects of life in the Arctic. Arctic temperatures are rising twice as fast as the global average. One of the most striking findings of climate science is Arctic amplification, the observation that the Arctic is warming roughly twice as fast as the rest of the planet. This accelerated warming is driven by several feedback loops. As ice melts, darker ocean and land surfaces are exposed, absorbing more heat. As the atmosphere warms, it holds more moisture, trapping more heat. As permafrost thaws, it releases greenhouse gases, further accelerating warming. The consequences of this rapid warming extend far beyond the Arctic. Changes in the Arctic affect weather patterns across the northern hemisphere, influencing everything from winter storms to summer droughts. The melting ice contributes to global sea level rise, threatening coastal communities worldwide. The Arctic is a bellwether, an early warning system for the changes that will eventually affect the entire planet. Understanding why the Arctic is warming so fast is a major focus of climate research. The region is both a victim of climate change and a driver of it, and the changes underway are reshaping the Earth's climate system in profound ways. Greenland's ice sheet is melting at an accelerating rate. Greenland, the world's largest island, is covered by an ice sheet containing enough frozen water to raise global sea levels by more than 7 meters if it melted completely. That melting is not a distant threat. It is happening now. Satellite measurements and field studies show that Greenland is losing ice at an accelerating rate, with billions of tons melting each year. The ice sheet is melting from both above and below. Warmer air temperatures cause surface melting, creating rivers and lakes on top of the ice. Some of this water drains through cracks to the bedrock below, lubricating the ice and accelerating its flow toward the ocean. Warmer ocean water erodes the ice from below, undercutting glaciers and causing massive chunks to break off in a process called calving. The loss of Greenland's ice is one of the largest contributors to sea level rise. Coastal cities around the world, from Miami to Mumbai, face increasing flood risks as the ice melts. The transformation of Greenland is a visible, measurable consequence of a warming planet, and it serves as a stark reminder of the stakes involved in climate change. The Greenland ice sheet has existed for millions of years. The ice covering Greenland is ancient, a relic of ice ages past. It has persisted for at least 2.5 million years, through countless cycles of warm and cold periods. During the coldest times, the ice sheet expanded, covering more of the Arctic. During warmer periods, it retreated, but never disappeared entirely. The ice sheet holds within it a record of Earth's climate history. Ice cores drilled from its depths reveal atmospheric conditions, volcanic eruptions, and even cosmic dust from hundreds of thousands of years ago. Each layer tells a story, and together they form a chronicle of the planet's past. But now, the ice sheet is shrinking faster than at any time in recorded history. The stability that allowed it to persist for so long is being challenged by unprecedented warming. Scientists warn that if warming continues, the ice sheet could reach a tipping point beyond which its loss becomes irreversible. The ancient ice that has shaped the Arctic for millions of years may not survive the current century. Icebergs carve from Greenland's glaciers. The edge of Greenland's ice sheet meets the ocean in a dramatic collision of ice and water. Glaciers, rivers of ice flowing slowly toward the sea, reach the coast and extend out over the water. The ice becomes unstable, cracking and breaking under its own weight and the action of waves. When a piece breaks free, it calves, crashing into the ocean with a roar and a splash that can be heard for kilometers. These icebergs can be enormous, the size of buildings or even small islands. They drift away from Greenland, carried by currents and winds into the North Atlantic. Some melt quickly in the relatively warm water. Others drift south, sometimes reaching the shipping lanes off Newfoundland, where they pose hazards to ships. The iceberg that sank the Titanic in 1912 likely originated from Greenland. Watching an iceberg carve is a powerful experience. The crack and groan of the ice, the slow tilt as the piece breaks free, the thunderous splash as it hits the water, all of it speaks to the immense forces at work. It is also a reminder of the changes underway, as carving events become more frequent in a warming world. Most of an iceberg's mass is hidden below the surface. The phrase, "tip of the iceberg," captures an important truth. Only about 10% of an iceberg's mass is visible above the water. The rest is submerged, hidden beneath the surface. This is because ice is less dense than seawater, but only slightly. The majority of the iceberg's volume must be underwater to provide buoyancy. The submerged portion of an iceberg can be vast, extending far below the surface in strange and irregular shapes. Divers who explore icebergs describe alien landscapes, cathedrals of ice glowing blue in the filtered light, carved into shapes by currents and melting. For ships, the hidden bulk of an iceberg is a serious hazard, capable of tearing through a hull even when the visible portion seems small. Icebergs are reminders that much of what we see is only a fraction of the whole. The Arctic holds hidden depths, both literal and metaphorical, and understanding them requires looking beneath the surface. Arctic sea ice reflects sunlight, cooling the planet. One of the most important roles the Arctic plays in the global climate system is its reflectivity. Sea ice is white, and white surfaces reflect most of the sunlight that hits them, bouncing it back into space. This process, called albedo, helps keep the planet cool. The Arctic acts as a giant mirror, preventing solar energy from being absorbed by the Earth. But when the ice melts, the effect reverses. The dark ocean water beneath the ice absorbs most of the sunlight, converting it to heat. This warms the water, which melts more ice, which exposes more dark water, creating a feedback loop. The loss of Arctic ice reduces the planet's overall albedo, accelerating global warming. This feedback is one reason the Arctic is so critical to the climate system. Changes at the pole ripple outward, affecting temperatures, weather, and ocean currents around the world. Protecting the Arctic ice is not just about preserving a remote wilderness. It is about maintaining a cooling system that benefits the entire planet. The jet stream is influenced by Arctic temperatures. High in the atmosphere, a river of fast-moving air called the jet stream circles the northern hemisphere. This current of wind separates cold Arctic air from warmer air to the south, and it drives weather patterns across North America, Europe, and Asia. The jet stream's path determines where storms go, where droughts occur, and how cold or warm different regions will be. The jet stream is influenced by the temperature difference between the Arctic and the mid-latitudes. A strong temperature gradient creates a fast, stable jet stream that flows in a relatively straight path. But as the Arctic warms faster than the rest of the planet, the temperature difference weakens and the jet stream becomes slower and wavier. It meanders, forming large loops that can bring Arctic cold far to the south or push warm air deep into the north. These changes in the jet stream have been linked to extreme weather events, severe winter storms, prolonged droughts, and unusual heat waves. The warming Arctic is not just a local phenomenon. It is reshaping weather across the hemisphere, affecting billions of people far from the ice. Warmer Arctic air can bring cold snaps to southern regions. One of the paradoxes of a warming Arctic is that it can lead to colder weather in places far to the south. When the jet stream weakens and meanders, it can create large dips that allow Arctic air to spill southward. This brings bitterly cold temperatures, heavy snow, and ice storms to regions that are not typically Arctic. These events are sometimes called Arctic outbreaks or polar vortex events. They are not signs that the planet is cooling, but rather symptoms of a disrupted climate system. The warmer Arctic destabilizes the atmospheric patterns that normally keep cold air confined to the north, allowing it to escape and affect areas as far south as Texas or the Mediterranean. For people experiencing these cold snaps, the connection to Arctic warming may seem counterintuitive, but climate is complex, and changes in one region can have surprising effects elsewhere. The Arctic and the rest of the world are connected through the atmosphere, and as the Arctic changes, the consequences spread. Snow and ice cover decline affects freshwater supplies. The Arctic is a major source of freshwater, stored in ice sheets, glaciers, and snow cover. When this ice melts, it flows into rivers and oceans, but the loss also affects the availability of fresh water for communities, agriculture, and ecosystems downstream. Rivers fed by Arctic glaciers provide water for millions of people, and as the glaciers shrink, the river's flow becomes more variable, with higher flows during melt season and reduced flows later in the year. Changes in snow cover also affect water supplies. Snow acts as a reservoir, storing water in winter and releasing it gradually in spring and summer. As the Arctic warms, snow falls later, melts earlier, and covers less area. This disrupts the timing and amount of water available, affecting everything from hydropower generation to irrigation. The decline of Arctic ice and snow is not just an environmental issue, but a water security issue, one that affects communities far from the polar regions. The North Pole, though remote, is connected to the rest of the world through the water it releases. The Arctic Ocean is becoming less salty due to ice melt. The Arctic Ocean is one of the least salty oceans, thanks to the input of fresh water from rivers and melting ice. But as ice melts at an accelerating rate, the ocean is becoming even less salty. This change in salinity, though small, has significant consequences for ocean circulation and marine life. Salinity affects the density of seawater, which in turn drives ocean currents. Freshwater from melting ice is less dense and floats on top of the saltier water below, creating layers that do not mix easily. This stratification can prevent nutrients from rising to the surface, affecting the productivity of the ocean and the food webs that depend on it. Changes in salinity also affect the formation of sea ice. Less salty water freezes more easily, but the ice that forms is weaker and more prone to melting. The feedback between ice melt, salinity, and ocean circulation is complex, and scientists are working to understand how these changes will reshape the Arctic Ocean in the coming decades. Plankton blooms beneath Arctic ice in spring. Even beneath the ice, the Arctic Ocean is alive. In spring, as sunlight returns and strengthens, microscopic organisms called phytoplankton begin to bloom. These tiny plants drift in the water, using sunlight to photosynthesize and produce energy. They form the base of the Arctic food web, feeding zooplankton, which in turn feed fish, seabirds, and whales. Traditionally, it was thought that phytoplankton could only bloom in open water or near the edge of the ice, where sunlight could penetrate. But recent discoveries have shown that blooms can occur beneath the ice, using light that filters through. Melt ponds on the ice surface, areas where the ice has thinned, act as windows, allowing enough light to reach the water below. These under-ice blooms are a reminder that life finds ways to adapt, even in the most challenging conditions. As the ice thins and melt ponds become more common, under-ice blooms may become more frequent, altering the timing and location of Arctic productivity. The Arctic Ocean supports unique cold-adapted fish. The fish of the Arctic Ocean are specially adapted to survive in water that hovers near freezing. Some species have antifreeze proteins in their blood, which prevent ice crystals from forming inside their cells. These proteins allow the fish to remain active even in water cold enough to freeze most other fish. Arctic cod is one of the most important species, a small fish that forms the link between plankton and larger predators like seals and seabirds. They gather in large schools beneath the ice, feeding on zooplankton and providing food for countless other animals. Other species, like sculpin and Arctic char, occupy different niches, some living on the seafloor, others swimming in the open water. As the Arctic warms, these cold-adapted fish face new challenges. Warmer water brings new species from the south, creating competition and changing the ecosystem. The fish that have thrived in the Arctic for millennia may find themselves in a world that no longer suits them, a world where the ice they depend on is disappearing. Bowhead whales can live over 200 years. The bowhead whale, one of the longest-lived mammals on Earth, inhabits the Arctic waters near the North Pole. These massive whales can live for more than 2 centuries, with some individuals estimated to be over 200 years old. They spend their entire lives in cold water, using their thick blubber, up to half a meter thick, to stay warm. Bowhead whales are filter feeders, using baleen plates in their mouths to strain tiny crustaceans called copepods from the water. They consume vast quantities, sometimes eating more than a ton of food per day. In winter, they use their massive heads to break through ice, creating breathing holes where they surface to breathe. Their longevity is remarkable. A bowhead whale alive today could have been born before the Industrial Revolution, before the Arctic was explored by Europeans, when the ice was thicker and the world was different. These whales are living links to the past, and their survival depends on the preservation of the Arctic environment. Belugas are known as the canaries of the sea. Beluga whales, with their distinctive white color and rounded heads, are one of the most vocal cetaceans. They produce a wide range of sounds, clicks, whistles, chirps, and squeals, earning them the nickname canaries of the sea. These vocalizations are used for communication, navigation, and hunting in the murky waters beneath the ice. Belugas are highly social, traveling in pods that can number in the hundreds. They migrate seasonally, moving between coastal areas in summer and the pack ice in winter. Their white coloration provides camouflage against the ice, protecting them from predators like orcas and polar bears. Belugas face numerous threats, from hunting by indigenous communities who have relied on them for food and materials for centuries, to pollution and shipping traffic. As the Arctic changes, their habitat is being altered, and the noise from increased shipping interferes with their ability to communicate and navigate. Protecting belugas means protecting the quiet, ice-covered waters they have called home for millennia. Orcas are expanding their range into the Arctic. As the ice retreats, orcas, also known as killer whales, are venturing farther into Arctic waters. These powerful predators, apex hunters of the ocean, have historically been limited by ice, which can trap them or restrict their movements. But with more open water, orcas are now regular visitors to the Arctic, hunting seals, fish, and even other whales. The arrival of orcas is changing the Arctic ecosystem. Prey species that once found refuge in ice-covered waters now face new predators. Beluga whales and narwhals, which evolved without significant orca predation, are particularly vulnerable. The presence of orcas is reshaping behaviors and populations, adding a new dynamic to an ecosystem already in flux. Orcas are adaptable and intelligent, and their expansion into the Arctic is a reminder that as the environment changes, so too do the species that inhabit it. The Arctic is not static but a living, evolving system, and the arrival of new predators is one more consequence of a warming world. Seabirds nest in massive colonies on Arctic coasts. During the brief Arctic summer, seabirds arrive in the millions to nest on cliffs and rocky shores. Species like murres, puffins, kittiwakes, and gulls gather in enormous colonies, the cliffs alive with the clamor of birds calling, squabbling, and tending their chicks. The colonies can stretch for kilometres, a cacophony of sound and a spectacle of life. These birds depend on the ocean for food, diving into the icy water to catch fish and invertebrates. They must time their breeding carefully, raising their chicks during the narrow window when food is abundant. If the ice breaks up too early or too late, if fish populations shift, or if weather is poor, breeding can fail and chick survival plummets. Seabird colonies are indicators of ocean health. Declines in populations signal problems in the marine food web, whether from overfishing, pollution, or climate change. Monitoring these colonies gives scientists insights into the state of the Arctic ecosystem and the challenges it faces. The little oak is one of the most numerous seabirds. Among the millions of seabirds in the Arctic, the little oak, or dovki, is one of the most abundant. These small, plump birds nest in colonies numbering in the millions on remote Arctic islands. They are specialist feeders, targeting tiny zooplankton that they catch during dives. Their numbers reflect the health of the plankton populations, and they are a key link in the Arctic food web. Little auks face numerous challenges. Climate change is shifting the timing of plankton blooms, potentially mismatching the birds' breeding with food availability. Introduced predators, like Arctic foxes on some islands, take a heavy toll on eggs and chicks, and longer-term warming seas may push plankton northward, forcing the birds to travel farther to feed. Despite these challenges, the little auk remains one of the Arctic's success stories, a small bird that thrives in one of Earth's harshest environments. Their colonies are a testament to the productivity of the Arctic Ocean and the resilience of the species that call it home. The Arctic fox changes coat color with the seasons. The Arctic fox is a master of disguise. In summer, its coat is brown or gray, blending with the rocky tundra and sparse vegetation. As winter approaches, the fox molts, and its fur turns brilliant white, matching the snow and ice. This seasonal camouflage helps the fox hunt and avoid predators, making it nearly invisible against its surroundings. The transformation is driven by the changing day length. As the days shorten, hormones trigger the molt, and the white winter coat grows in. When the days lengthen again in spring, the process reverses. The fox is perfectly attuned to the Arctic's seasonal rhythms, its appearance shifting with the environment. This adaptability extends beyond fur color. Arctic foxes can survive temperatures as low as -70 degrees Celsius, thanks to their dense fur, compact bodies, and efficient metabolism. They are opportunistic feeders, scavenging, hunting, and storing food for leaner times. In a landscape of extremes, the Arctic fox is a survivor, shaped by millennia of evolution in the harshest conditions. Lemmings are crucial prey for Arctic predators. Lemmings, small rodents no larger than a hamster, are among the most important animals in the Arctic tundra. They are the primary prey for a host of predators, including Arctic foxes, snowy owls, weasels, and birds of prey. When lemming populations are high, predators thrive, raising large families and expanding their ranges. When lemming populations crash, predators struggle, and their numbers decline. Lemming populations cycle dramatically, surging and collapsing every few years in response to food availability, predation, and weather. These cycles ripple through the Arctic ecosystem, affecting everything from plant growth to bird migrations. In years of high lemming abundance, the tundra feels alive with activity. In crash years, it can seem eerily quiet. Despite their small size, lemmings shape the Arctic. Their grazing affects plant communities, their burrows aerate the soil, and their role as prey supports a web of life. To understand the Arctic is to understand the lemming, a small creature with an outsized impact. Caribou migrate thousands of kilometers each year. Caribou, known as reindeer in Eurasia, undertake some of the longest migrations of any land mammal. Herds numbering in the thousands travel across the tundra, moving between calving grounds in the north and wintering areas farther south. These migrations can cover more than 3,000 kilometers in a year, a continuous cycle of movement in search of food and favorable conditions. The timing of migration is critical. Calves are born in late spring on the tundra, where they are relatively safe from predators and where vegetation is beginning to green. As summer progresses, the herds move to take advantage of fresh growth and to escape biting insects. In autumn, they head south, ahead of the deep snows and harsh weather. Climate change is disrupting these ancient patterns. Earlier springs mean plants green up before the caribou arrive, and by the time the herds reach their calving grounds, the nutritious new growth has already toughened. Warmer winters bring more freeze-thaw cycles, creating ice layers that prevent caribou from accessing food beneath the snow. Herd numbers are declining, and the migrations that have defined the Arctic for millennia are under threat. Muskoxen are relics of the Ice Age. Muskoxen, with their shaggy coats and curved horns, look like creatures from another time, and in a sense, they are. They are survivors of the Pleistocene Ice Age, when they roamed across the Arctic alongside mammoths and saber-toothed cats. When the ice retreated and most megafauna went extinct, muskoxen persisted, adapted to life in the cold. Muskoxen are built for the Arctic. Their long, thick fur, called chiviot, is one of the warmest natural fibers in the world. They live in small herds and use a defensive formation when threatened, forming a circle with their young in the center and their horns facing outward. This strategy works well against wolves, their primary predator, but is less effective against human hunters. Today, muskoxen are found across the Arctic, from Greenland to Alaska. They are a living connection to the Ice Age, a reminder of a time when the Arctic was dominated by great herds of large mammals. Their survival is a testament to their resilience, but like all Arctic species, they face an uncertain future in a rapidly changing world. The tundra blooms briefly in summer. For most of the year, the Arctic tundra is a frozen, lifeless landscape. But in summer, a transformation occurs. Snow melts, the ground thaws, and the tundra erupts in a brief explosion of color and life. Wildflowers bloom, carpets of moss turn green, and the air fills with the buzz of insects and the calls of birds. This bloom is fleeting, lasting only a few weeks before the cold returns. Plants must grow, flower, and set seed in this narrow window, racing against the inevitable freeze. The tundra in summer is a place of urgency and beauty, life compressed into a brief moment of warmth and light. For those who witness it, the summer tundra is unforgettable. The contrast between the barren winter landscape and the vibrant summer one is stark, a reminder of nature's resilience and the power of the sun to bring life even to the coldest places. Permafrost thaw creates thermokarst landscapes. When permafrost thaws, the ground does not simply soften, it collapses. The ice within the permafrost melts, leaving voids that cause the surface to subside unevenly. This creates a landscape called thermokarst, characterized by sinkholes, slumping hillsides, and irregular depressions filled with water. Thermokarst landscapes are chaotic and unstable. Lakes form suddenly as the ground collapses, and hillsides slump, carrying soil and vegetation downslope. Buildings, roads, and infrastructure built on permafrost can be destroyed as the ground shifts beneath them. For communities in the Arctic, thawing permafrost is a crisis, threatening homes, water supplies, and traditional ways of life. Thermokarst also affects ecosystems. New lakes provide habitat for fish and waterfowl, but can also drown vegetation and release stored carbon. The transformation of the tundra through permafrost thaw is one of the most visible signs of Arctic change, a landscape in upheaval. Pingos are ice-cored hills found in the Arctic. Among the unique features of the Arctic landscape are pingos, dome-shaped hills with cores of ice. They form when groundwater under pressure freezes, expanding and pushing the overlying soil upward. Over time, the ice core grows and the hill rises, sometimes reaching heights of 50 meters or more. Pingos are most common in areas with permafrost, and they can last for centuries. But if the ice core melts, the pingo collapses, leaving a circular depression. These features are indicators of permafrost conditions, and their formation and collapse can tell scientists about changes in the frozen ground. To see a pingo is to witness one of the Arctic's stranger landforms, a hill built not of rock but of ice, a temporary feature in a landscape shaped by freeze and thaw. Glacial ice appears blue due to compressed snow. One of the most beautiful sights in the Arctic is the deep blue of glacial ice. Unlike the white of fresh snow, old ice glows with an intense blue color, especially in crevasses and ice caves. This color comes from the way ice absorbs light. As snow is compressed into ice, air bubbles are squeezed out, creating dense, pure ice. When light enters this ice, the red wavelengths are absorbed, while the blue wavelengths are scattered and reflected back. The thicker the ice, the deeper the blue. In some places, the ice is so blue it seems almost unnatural, a vivid azure that contrasts sharply with the white snow and gray sea. To see blue glacial ice is to look at snow that fell hundreds or thousands of years ago, compressed and transformed by time and weight. It is a glimpse into the past, frozen in a color that captures the imagination and reminds us of the beauty hidden in the Arctic. Ice caves form within glaciers from meltwater. Within glaciers and ice sheets, rivers of meltwater carve tunnels and caves. These ice caves are fragile and temporary, forming during summer when melt is at its peak and collapsing or freezing shut in winter. But while they exist, they are among the most spectacular natural wonders of the Arctic. Inside an ice cave, the world transforms. The walls glow blue, lit by sunlight filtering through the ice. The air is cold and still, the only sound the drip of water. The surfaces are smooth, sculpted by flowing water into organic flowing shapes. Stalactites of ice hang from the ceiling, and pools of meltwater reflect the blue glow. Exploring an ice cave is dangerous. The ice can shift, crack, or collapse without warning. But for those who venture inside, the experience is otherworldly, a journey into a hidden world where ice shapes itself into cathedrals of light. The Arctic holds evidence of ancient volcanic activity. The Arctic landscape bears scars of volcanic activity from millions of years ago. In some regions, basalt formations, ancient lava flows, and volcanic ash layers reveal a time when the Arctic was volcanically active. These features are now frozen and eroded, but they tell a story of a dynamic geological past. Volcanic activity played a role in shaping the Arctic climate. Massive eruptions could inject ash and gases into the atmosphere, cooling the planet and influencing ice ages. The presence of volcanic rocks also affects the landscape, creating distinct landforms and influencing soil chemistry. Today, the Arctic is geologically quiet, but the remnants of its volcanic past remain, a reminder that the Earth's crust is active and that the Arctic has been shaped by forces both hot and cold over its long history. The Arctic tundra stores vast amounts of carbon. Beneath the frozen surface of the tundra lies a vast reservoir of carbon, stored in the remains of plants and animals that have accumulated over thousands of years. Because the ground is frozen, organic material does not decompose. Instead, it remains locked in the permafrost, a massive carbon sink that has kept this carbon out of the atmosphere. But as the permafrost thaws, this carbon is being released. Microbes in the thawing soil begin to break down the organic matter, producing carbon dioxide and methane. The release of this carbon adds to greenhouse gas concentrations, accelerating warming and creating a feedback loop. The more the permafrost thaws, the more carbon is released, leading to more warming and more thawing. Scientists estimate that the Arctic permafrost contains more carbon than is currently in the atmosphere. The potential release of this carbon is one of the most concerning aspects of Arctic change, a tipping point that could dramatically accelerate global warming. Snow cover reflects sunlight and keeps the Arctic cool. Snow, like ice, is highly reflective. It bounces back most of the sunlight that hits it, preventing the Earth from absorbing heat. This reflectivity is crucial for maintaining the Arctic's cold climate. When snow covers the ground, it keeps the surface cool, even during the summer when the sun shines continuously. But as temperatures rise and snow cover declines, more dark ground and vegetation are exposed. These surfaces absorb more heat, warming the soil and the air above it. This creates a feedback loop. Less snow means more warming, which means even less snow. The decline in snow cover is one of the most visible signs of Arctic change. Satellite images show that snow is melting earlier in spring and arriving later in autumn, shrinking the period when the land is white. This loss of snow cover contributes to regional and global warming, another way the Arctic influences the planet's climate. Polar stratospheric clouds form in the cold Arctic winter. High above the Arctic, in the stratosphere, unusual clouds form during the coldest parts of winter. These polar stratospheric clouds, also called nacreous or mother-of-pearl clouds, are composed of ice crystals and form only when temperatures drop below -78 degrees Celsius. They shimmer with iridescent colors, blues, greens, and pinks, creating a stunning display in the polar sky. These clouds are beautiful, but they also play a troubling role in atmospheric chemistry. They provide surfaces where chemical reactions occur, reactions that destroy ozone. The ozone layer protects life on Earth from harmful ultraviolet radiation, and its depletion over the Arctic is a concern for scientists. The formation of polar stratospheric clouds is a reminder that the Arctic atmosphere is unique, a place where extreme cold creates phenomena found nowhere else on Earth. These clouds are another piece of the Arctic's intricate system, beautiful and scientifically significant. The ozone layer thins over the Arctic in spring. During the Arctic winter, the stratosphere becomes extremely cold, and polar stratospheric clouds form. These clouds facilitate chemical reactions that break down ozone, the molecule that shields Earth from ultraviolet radiation. When the sun returns in spring, these reactions accelerate, and the ozone layer thins, sometimes forming a hole similar to the one over Antarctica. The Arctic ozone hole is smaller and less persistent than its Antarctic counterpart, but it is still a concern. Increased ultraviolet radiation can harm living organisms, causing skin cancers, cataracts, and damage to phytoplankton in the ocean. Monitoring the ozone layer is an important part of atmospheric research in the Arctic. Efforts to reduce ozone-depleting chemicals, like those in the Montreal Protocol, have been successful, and the ozone layer is slowly recovering. But the Arctic remains vulnerable, and scientists continue to watch for signs of depletion, especially as the climate changes and stratospheric temperatures fluctuate. Indigenous knowledge is vital for Arctic research. Indigenous peoples have lived in the Arctic for thousands of years, accumulating knowledge about the land, ice, and animals. This knowledge, passed down through generations, is invaluable for understanding the Arctic and predicting changes. Indigenous hunters can read ice conditions with a precision that satellites cannot match, and their observations of animal behavior and weather patterns provide insights that complement scientific data. Increasingly, researchers are partnering with indigenous communities, combining traditional knowledge with modern science. This collaboration enriches understanding and ensures that indigenous voices are heard in decisions about the Arctic's future. It also respects the fact that indigenous peoples have a deep, lived connection to the land, one that goes beyond data and measurements. Recognizing the importance of indigenous knowledge is not just about improving research, it is about honoring the people who have been stewards of the Arctic long before it became a subject of global concern. Their knowledge is a treasure, one that must be preserved and valued. The concept of polar night has inspired art and literature. The long darkness of the polar night has captivated artists, writers, and filmmakers for generations. It is a time of mystery and introspection, when the world is transformed by the absence of the sun. Works of art depicting the Arctic often focus on this darkness, the interplay of shadow and light, the eerie beauty of the aurora, and the isolation of the frozen landscape. Literature set in the Arctic frequently explores themes of endurance, madness, and the sublime power of nature. The polar night becomes a character in its own right, a force that tests the limits of human resilience. From the journals of early explorers to modern novels and films, the Arctic's darkness has inspired stories of survival, wonder, and the fragility of life in extreme environments. For those who have never experienced it, the polar night is almost unimaginable. But through art and literature, its essence is captured, shared with those who will never stand beneath the dark Arctic sky, yet can still feel its pull. The midnight sun has also inspired cultural celebrations. Just as the polar night has its place in culture, so too does the midnight sun. In Arctic communities, the return of the sun after months of darkness is a cause for celebration. Festivals mark the summer solstice, when the sun reaches its highest point and the days are longest. These celebrations are joyful, filled with music, dancing, and gatherings that extend late into the bright night. For indigenous peoples, the midnight sun has always been a time of activity, of hunting, fishing, and preparing for the winter ahead. The continuous daylight allows for extended work and travel, and the warmth, though brief, is treasured. Today, these traditions continue, blending ancient customs with modern life. The midnight sun is also a draw for tourists, who travel to the Arctic to experience the surreal phenomenon of a sun that never sets. Standing outside at midnight, with the sun still shining, is an experience that stays with people, a reminder of the Earth's tilt and the unique rhythms of the polar regions. The North Pole has no permanent human settlement. Unlike the South Pole, which has research stations with year-round staff, the North Pole has no permanent human presence. The ice is too unstable, constantly drifting and shifting. making it impossible to build a lasting structure. Temporary camps are set up for research or tourism, but these are dismantled and removed when the ice begins to break up. This lack of permanent settlement gives the North Pole a sense of purity and isolation. It is a place that remains largely untouched by human hands, a frontier that cannot be claimed or permanently occupied. For all our technology and ambition, the North Pole resists our attempts to stay, reminding us that some places on Earth remain wild and beyond our control. The absence of permanent settlement also means the North Pole exists in a state of constant motion, a point defined by coordinates, but with no fixed physical presence. It is both everywhere and nowhere, a concept as much as a place. Climate models predict continued Arctic warming. Scientists use climate models to project future changes in the Arctic. These models, which simulate the Earth's climate system, consistently show that the Arctic will continue to warm, likely at a faster rate than the rest of the planet. Even if global efforts to reduce greenhouse gas emissions succeed, some degree of warming is already locked in, the result of gases already in the atmosphere. The models vary in their details, but the overall trend is clear. By the end of this century, the Arctic could be radically different. Summers may be ice-free, permafrost could thaw extensively, and ecosystems could shift in ways that are difficult to predict. The changes will affect not just the Arctic, but the entire planet, through rising sea levels, altered weather patterns, and the release of stored carbon. These projections are not certainties, but they are based on the best available science. They serve as warnings, highlighting the urgency of addressing climate change. The future of the North Pole is not yet written, but the path we are on leads to a profoundly altered Arctic. Feedback loops accelerate Arctic change. One reason the Arctic is changing so rapidly is the presence of feedback loops, processes that amplify warming. The ice albedo feedback is the most well-known. As ice melts, darker surfaces are exposed, which absorb more heat, leading to more melting. But there are others. Thawing permafrost releases methane and carbon dioxide, which trap more heat, leading to more thawing. Warmer air holds more moisture, which acts as a greenhouse gas, trapping more heat. These feedbacks create a system where change accelerates over time. Small initial changes can lead to much larger effects as the system amplifies itself. Breaking these feedback loops requires reducing greenhouse gas emissions and stabilizing temperatures, a task that becomes more difficult as the feedbacks strengthen. Understanding feedbacks is crucial for predicting the Arctic's future. They are the mechanisms through which small changes become large ones, and they highlight the interconnectedness of the Arctic system. The North Pole is not an isolated region, but part of a complex, dynamic planet where changes in one area ripple outward. Some species are adapting to the changing Arctic, while many Arctic species are threatened by climate change. Some are showing signs of adaptation. Populations are shifting northward, following the ice and cooler temperatures. Breeding cycles are adjusting to earlier springs, and some species are changing their diets or behaviors to cope with new conditions. These adaptations are not guaranteed to succeed, and they come with costs. Animals that must travel farther to find food expend more energy, reducing their chances of survival. Shifts in distribution can lead to conflicts with other species or with humans, and the pace of change may be too fast for evolution to keep up. Still, the resilience of Arctic species is remarkable. Life has persisted in the Arctic through ice ages and warm periods, through extinctions and colonizations. The current changes are unprecedented in speed, but life has proven itself adaptable. The question is whether the pace of change will allow that adaptability to manifest, or whether it will overwhelm the Arctic's remarkable inhabitants. New species are moving into the Arctic from the south. As the Arctic warms, species from temperate regions are expanding northward. Fish, birds, and even trees are appearing in areas where they were previously absent. This shifts the composition of Arctic ecosystems, creating new interactions and competitions. Some of these new arrivals are invasive, outcompeting native species for resources. Others fill niches left vacant by declining Arctic species. The result is an ecosystem in flux, a mix of old and new that is still sorting itself out. For scientists, tracking these changes is a challenge, as the Arctic becomes a meeting ground for species from different regions. The movement of species northward is a visible sign of climate change, one that can be observed without instruments or models. It is a reminder that ecosystems are not static, that they respond to environmental changes by shifting, adapting, and reorganizing. Arctic tourism is growing, but brings environmental concerns. As the Arctic becomes more accessible, tourism is increasing. Cruise ships navigate newly ice-free waters, bringing passengers to see glaciers, wildlife, and the midnight sun. Adventurers trek to the North Pole, guided by experienced teams, and photographers flock to capture the beauty of the aurora and the ice. Tourism brings economic benefits to Arctic communities, providing jobs and income, but it also brings risks. Ships can disturb wildlife, introduce pollution, and contribute to the noise that interferes with marine mammals. Increased foot traffic can damage fragile tundra ecosystems, and the carbon emissions from travel contribute to the very warming that is making the Arctic accessible. Balancing tourism with conservation is a challenge. Some argue for stricter limits on visitors, protecting the Arctic from the impacts of human presence. Others see tourism as a way to raise awareness and support for Arctic conservation. The debate is ongoing, as the Arctic grapples with becoming a destination rather than a distant wilderness. The Arctic is a refuge for migratory birds. Every summer, millions of birds migrate to the Arctic to breed. They come from as far away as South America, Africa, and Southeast Asia, drawn by the abundance of food and the relative safety from predators. The tundra and coastal areas teem with insects, fish, and invertebrates, providing a feast for hungry chicks. These migrations are among the longest and most arduous in the animal kingdom. Arctic terns fly from Antarctica to the Arctic and back, each year a round trip of over 70,000 kilometers. Shorebirds travel thousands of kilometers from tropical wintering grounds to Arctic breeding areas. The Arctic summer is brief, but it is rich, and birds time their arrivals to coincide with the peak of food availability. The Arctic serves as a nursery for these migratory species, but changes in timing due to climate change threaten this relationship. If birds arrive too early or too late, the food they need may not be available, leading to breeding failures. The Arctic's role as a refuge depends on the synchrony between migration and food availability, a balance that is being disrupted. The Arctic connects to the rest of the world through migratory species. The birds, whales, and fish that breed or feed in the Arctic do not stay there year-round. They migrate, connecting the Arctic to ecosystems thousands of kilometers away. A whale that feeds in Arctic waters may winter in the Caribbean. A bird that nests on the tundra may spend winter in South America. These migrations link the Arctic to the rest of the planet, making it part of a global network. Changes in the Arctic ripple through these connections. Declines in Arctic fish populations affect seabirds that migrate to the tropics. Loss of sea ice impacts whales that travel across oceans. The Arctic is not isolated but interconnected, and its health affects species and ecosystems far beyond its borders. Understanding these connections is crucial for conservation. Protecting migratory species requires protecting their entire range, from Arctic breeding grounds to tropical wintering areas. The North Pole, though remote, is part of a global system, and its fate is tied to the fate of the planet. Scientists use satellites to monitor Arctic ice. Satellites orbiting high above the Earth provide a constant stream of data about the Arctic. They measure ice extent, thickness, and movement. They track temperatures, snow cover, and vegetation. They observe changes in real time, providing a comprehensive view of the Arctic that would be impossible to achieve from the ground alone. This satellite data is essential for understanding Arctic change. It shows trends over decades, revealing patterns that might not be visible year to year. It allows scientists to monitor remote areas that are difficult or impossible to reach, and it provides data that feeds into climate models, improving predictions of future changes. The use of satellites has revolutionized Arctic research, turning the region from a place of mystery into one of the most closely monitored areas on Earth. Every day, satellites pass over the North Pole, recording data that helps us understand what is happening at the top of the world. Remote sensing technology reveals hidden Arctic features. Beyond visible light, satellites use a range of sensors to study the Arctic. Radar can penetrate clouds and darkness, providing images even during polar night. Infrared sensors detect heat, revealing temperature differences in the ice and ocean. Specialized instruments measure ice thickness by bouncing signals off the ice and timing the return. These technologies reveal features that are invisible to the naked eye. Thin ice, which looks similar to thick ice from above, can be distinguished by radar. Ocean currents beneath the ice can be inferred from surface temperatures. Changes in vegetation can be tracked through shifts in reflected light. Remote sensing has opened a window into the Arctic, allowing scientists to see beyond what is visible and to understand processes that occur hidden beneath the ice and snow. It is a powerful tool, one that continues to improve as technology advances. The North Pole is a symbol of environmental change. For many people, the North Pole represents the front line of climate change. Images of melting ice, struggling polar bears, and vanishing glaciers have become iconic symbols of environmental crisis. The Arctic's transformation is visible and dramatic, making it a powerful tool for communicating the reality of climate change. This symbolism is both a strength and a challenge. It raises awareness and motivates action, but it can also oversimplify complex issues or lead to despair. The Arctic is changing, but it is not yet lost. There is still time to act, to reduce emissions, and to protect what remains. The North Pole as a symbol reminds us that climate change is not abstract, but real, affecting places and creatures we care about. It challenges us to think about our impact on the planet and to consider what kind of world we want to leave for future generations. International cooperation is essential for Arctic preservation. The Arctic cannot be saved by any one nation. It requires cooperation across borders, between governments, scientists, indigenous communities, and organizations. The challenges are too large and interconnected for isolated efforts to succeed. International agreements, like those on climate change, fisheries management, and pollution control, are crucial. The Arctic Council facilitates dialogue and collaboration, though it faces challenges as geopolitical tensions rise. Scientific cooperation continues, with researchers from different nations working together to understand and protect the Arctic. The North Pole, belonging to no single country, embodies the need for global cooperation. It is a shared resource, a place that affects and is affected by the entire planet. Protecting it requires us to look beyond national interests and to recognize our common stake in the Arctic's future. The Arctic inspires scientific discovery and wonder. The North Pole and the broader Arctic region have always been places of discovery. From early explorers mapping unknown coastlines to modern scientists uncovering the secrets of climate and ice, the Arctic pushes the boundaries of human knowledge. It challenges us with its extremes and rewards us with insights that reshape our understanding of the planet. Every expedition to the Arctic, whether by ship, sled, or satellite, adds to our knowledge. Every measurement, every observation contributes to a growing picture of how the Arctic works and how it is changing. The discoveries made in the Arctic have implications far beyond the region, informing our understanding of oceans, atmospheres, and the interconnected systems that sustain life on Earth. The Arctic also inspires wonder. To stand at the North Pole, or to see the aurora, or to watch a polar bear on the ice, is to feel a sense of awe at the natural world. This wonder is not just emotional, but motivational, driving us to learn more, to protect what we have, and to ensure that future generations can experience the Arctic's beauty and majesty. The silence of the Arctic is profound and restorative. One of the most striking features of the Arctic is its silence. With no trees to rustle, no insects to hum in winter, and vast distances between any sources of sound, the Arctic can be profoundly quiet. The silence is almost tangible, a presence in itself, broken only by the occasional crack of ice, the call of a distant bird, or the whisper of wind. This silence is restorative. In a world filled with noise, the Arctic offers a refuge, a place where you can hear your own thoughts clearly. For researchers who spend time in the Arctic, the silence is often mentioned as one of the most memorable aspects, a deep quiet that allows for reflection and contemplation. But the silence is also fragile. As human activity increases, noise from ships, aircraft, and machinery intrudes. The Arctic is no longer as quiet as it once was, and for wildlife that depends on sound for communication and navigation, this noise is a disruption. Preserving the Arctic's silence is part of preserving its character, ensuring it remains a place apart from the noise of modern life. The beauty of the Arctic changes with each season. The Arctic is not one landscape but many, shifting with the seasons. In winter, it is a world of white and blue, ice and snow stretching to the horizon, the sky dark and filled with stars. In spring, the sun returns, and the ice begins to crack and shift, leads opening to reveal dark water. Summer brings transformation. The ice retreats, the tundra blooms, and life explodes in a brief, intense burst. Colors appear: greens, yellows, purples, and reds, painting the landscape in hues unseen during winter. The midnight sun bathes everything in golden light, and the air fills with the sounds of birds and insects. Autumn is a time of transition. The sun sinks lower, the colors fade, and the ice begins to form again. The world prepares for winter, animals migrating or storing food, plants going dormant. Each season has its own beauty, its own character, and together they create a cycle that has repeated for millennia, a rhythm that defines the Arctic. Ice crystals in the air create sun halos and arcs. The cold Arctic air is often filled with tiny ice crystals, too small to see individually, but collectively creating stunning optical effects. Sun halos, rings of light encircling the sun, are common. So are sundogs, bright spots on either side of the sun. And sometimes, under the right conditions, complex displays appear: arcs, pillars, and circles of light that fill the sky. These phenomena occur when sunlight passes through or reflects off ice crystals suspended in the air. The hexagonal shape of ice crystals bends light at specific angles, creating patterns of light that are both predictable and beautiful. Ancient peoples often saw these displays as omens, but today we understand their physics while still marveling at their beauty. To see a complex ice crystal display is to witness the interplay of light and ice, simple physics creating art in the sky. The Arctic, with its abundance of ice crystals, is one of the best places on Earth to see these phenomena, and they are a reminder of the hidden beauty in the air around us. Snowflakes in the Arctic can be uniquely shaped. The Arctic cold creates conditions ideal for intricate snowflakes. The classic six-sided symmetry of snowflakes is well known, but in the Arctic, the variations are endless. Each snowflake forms as water vapor freezes around a nucleus, building layer by layer. The exact shape depends on temperature, humidity, and the path the snowflake takes as it falls. In the coldest conditions, snowflakes can be simple columns or plates. In slightly warmer conditions, they develop the intricate branching patterns we associate with snowflakes. No two snowflakes are exactly alike, a fact that captures the imagination and highlights the complexity of even the simplest natural processes. For indigenous peoples and researchers in the Arctic, different types of snow have different names and properties. Some snow is light and fluffy, ideal for building igloos. Other snow is dense and hard, good for travel. Understanding snow is essential for survival in the Arctic, and the diversity of snowflakes reflects the diversity of conditions in which they form. The Arctic preserves a record of Earth's history. The ice, permafrost, and sediments of the Arctic contain a detailed record of Earth's past. Ice cores preserve atmospheric gases, dust, and isotopes that reveal past temperatures and climate conditions. Permafrost holds organic material, seeds, and even intact organisms from thousands of years ago. Sediment layers beneath the ocean and on land record changes in sea level, ice extent, and biological activity. By studying these records, scientists can reconstruct the history of the planet, understanding how climate has changed over hundreds of thousands of years. They can see the cycles of ice ages and warm periods, the impacts of volcanic eruptions and asteroid impacts, and the long, slow processes that shape the Earth. The Arctic is a library of deep time, a repository of information that stretches back far beyond human history. Every layer, every bubble, every grain holds a piece of the story, and together they tell us where we have been and where we might be going. Ancient ice holds secrets about past atmospheres. The oldest ice cores from Greenland and Antarctica contain ice that is hundreds of thousands of years old. Within this ice are bubbles of ancient air, preserved exactly as they were when the snow fell. Analyzing these bubbles allows scientists to measure past concentrations of greenhouse gases, revealing how the atmosphere has changed over time. These measurements show that carbon dioxide and methane levels have risen and fallen in cycles, closely linked to ice ages and warm periods. The data also shows that current levels of these gases are far higher than anything seen in the ice core record, a clear signal of human influence. The ancient ice is a witness to the past, a frozen archive that tells us about the planet's climate history. It is also a warning, showing us that the current changes are unprecedented and that we are entering a new era in Earth's climate. The North Pole is a place of extremes and contrasts. The North Pole embodies extremes. It is one of the coldest places on Earth, yet it can experience periods of relative warmth. It has 6 months of continuous daylight, followed by 6 months of darkness. It is covered by ice that is constantly moving, a solid surface on a liquid ocean. It is a place of profound silence, yet it is filled with the sounds of cracking ice and calling wildlife. These contrasts make the North Pole endlessly fascinating. It is a place that defies easy categorization, that challenges our understanding, and that rewards those who take the time to explore and learn. The extremes of the Arctic push life to its limits, revealing the resilience and adaptability of organisms and ecosystems. For those who visit or study the North Pole, the contrasts are what make it memorable. The interplay of light and dark, warmth and cold, silence and sound, creates a landscape that is both harsh and beautiful, unforgiving and awe-inspiring. The vastness of the Arctic is humbling. The Arctic is immense, covering millions of square kilometers of ocean, ice, and land. To stand in the Arctic is to feel small, dwarfed by the scale of the landscape. The horizon stretches endlessly, the sky is vast, and the ice seems to go on forever. There are no mountains, no forests, no features to break the monotony, only white and blue stretching in all directions. This vastness is humbling. It reminds us of how small we are, how limited our perspective, and how much of the world remains beyond our control. It also inspires a sense of freedom, a feeling that in such a place, anything is possible, that the rules of ordinary life do not apply. The Arctic's vastness is part of its appeal. It is a place where you can escape the crowded, noisy world and experience a landscape that feels infinite, where the only limits are those imposed by the environment and your own endurance. The Arctic night sky is among the clearest on Earth. The Arctic, with its cold, dry air and lack of light pollution, offers some of the clearest skies on the planet. On a dark winter night, the stars shine with a brilliance rarely seen elsewhere. The Milky Way stretches across the sky, a river of light made up of billions of stars. Planets are bright and steady, and meteors streak across the heavens with surprising frequency. For astronomers, the Arctic is an ideal location for observing the heavens. Observatories have been built in Arctic regions to take advantage of the clear skies and long nights. For casual stargazers, simply stepping outside and looking up is enough to be awed by the display. The clarity of the Arctic sky is a gift, a reminder of the beauty of the universe and our place within it. It is a place where the cosmos feels close, where the stars seem almost within reach, and where the vastness of space is laid bare. The stars appear brighter and more numerous in the Arctic. Without the haze, humidity, and light pollution of lower latitudes, the Arctic sky reveals stars that are invisible elsewhere. Faint stars, barely perceptible in other locations, shine clearly in the Arctic. Constellations are filled with more points of light, and the overall impression is of a sky densely packed with stars. This clarity allows observers to see deep sky objects like galaxies, nebulae, and star clusters with the naked eye or simple telescopes. The experience of watching the stars from the Arctic is transformative, a reminder of how much we miss when we live under bright, hazy skies. For those who experience the Arctic night sky, it often becomes one of the most memorable aspects of their time in the region. The stars are not just points of light, but a connection to the universe, a view unchanged for thousands of years, shared by every human who has ever looked up from the frozen north. Meteorites are sometimes found on Arctic ice. The white expanse of Arctic ice provides a perfect backdrop for finding meteorites, fragments of asteroids and comets that have fallen to Earth. Against the ice, the dark stones stand out clearly, making them easier to spot than in other environments. Scientists searching for meteorites often travel to Antarctica and the Arctic, where the ice preserves and concentrates these cosmic visitors. Meteorites found in the Arctic come from all over the solar system. Some are fragments of asteroids, others from the Moon or even Mars. Each meteorite is a piece of the early solar system, a sample of the material that formed the planets. Studying them provides insights into the building blocks of worlds and the processes that shaped our cosmic neighborhood. Finding a meteorite on the ice is like discovering a message from space, a tangible connection to the universe beyond our planet. The Arctic, with its cold and ice, preserves these visitors, protecting them until they can be found and studied. The Arctic connects us to the cosmos. The North Pole is a place where Earth meets the heavens. The aurora, caused by solar wind, links us to the sun. The clear night sky reveals the stars and galaxies beyond. Meteorites fall from space and land on the ice. The Arctic is a place where the cosmos feels close, where the boundary between Earth and space seems thin. This connection is not just physical, but also conceptual. The Arctic reminds us that Earth is part of a larger system, a planet orbiting a star in a galaxy among billions. It reminds us that we are made of elements forged in stars, that the ice and the aurora and the meteorites are all part of the same cosmic story. To stand at the North Pole is to stand at a point that feels almost otherworldly, a place where the familiar rules of day and night do not apply, where the landscape is alien and beautiful, and where the cosmos is always present, visible and tangible in the sky above. The future of the North Pole is uncertain. The North Pole as we know it today is changing rapidly. The ice is thinning, the temperatures are rising, and the ecosystem is in flux. What the North Pole will look like in 50 or 100 years is uncertain. Climate models provide projections, but the future depends on the choices we make today. If greenhouse gas emissions continue unabated, the Arctic could transform beyond recognition, with ice-free summers, altered ecosystems, and consequences that ripple across the globe. If we act to reduce emissions and limit warming, some of these changes could be slowed or even partially reversed. The uncertainty is both a challenge and a call to action. The future is not fixed, and the North Pole's fate is in our hands. What we do now will determine whether the Arctic remains a place of ice and wonder or becomes something fundamentally different. Every individual can contribute to Arctic preservation. The challenges facing the Arctic can feel overwhelming, but every person can make a difference. Reducing energy use, supporting renewable energy, and making sustainable choices all contribute to lowering greenhouse gas emissions. Advocating for climate policies, supporting conservation organizations, and raising awareness all help build the political will needed for change. Even small actions matter. The Arctic is far away for most people, but it is connected to our lives through the climate system, through migratory species, and through the global economy. Protecting the Arctic is not just about saving a distant wilderness. It is about ensuring the stability of the planet's climate and the health of ecosystems everywhere. Each of us is part of the story of the North Pole. Our choices, our actions, and our voices shape its future. The Arctic's fate is not separate from our own. It is intertwined, and what happens there will affect us all. The North Pole reminds us of Earth's fragility. The Arctic, for all its ice and cold, is fragile. The ecosystem is finely balanced, adapted to specific conditions that are now changing. The ice that has defined the region for millennia is disappearing. The species that have thrived there are struggling. The changes happening in the Arctic are a reminder that Earth's systems are not invincible, that they can be disrupted, and that we have the power to cause harm. But fragility also means vulnerability, and with that comes the potential for protection. The Arctic can be saved, but it requires effort, commitment, and a willingness to change. The North Pole is a call to action, a reminder that we are stewards of this planet and that our choices matter. To think of the North Pole is to think of ice and cold, of auroras and polar bears, of silence and vastness. but it is also to think of change, of loss, and of hope. The future of the North Pole is unwritten, and we have the opportunity to shape it, to ensure that this remarkable place endures for generations to come. The Arctic holds lessons for humanity. The Arctic teaches us about resilience, about adaptation, and about the limits of life. It shows us what is possible when conditions are extreme, and how ecosystems can thrive in places that seem inhospitable. It also teaches us about interconnectedness, about how changes in one region affect the entire planet. The Arctic teaches humility. It is a place where human ambition meets natural limits, where the environment is harsh and unforgiving, and where survival requires respect for the forces of nature. Explorers, researchers, and indigenous peoples have all learned this lesson, understanding that the Arctic demands caution, preparation, and reverence. The Arctic also teaches hope. Life persists there, beautiful and diverse, despite the cold and the darkness. If life can thrive at the North Pole, it can thrive anywhere. The resilience of Arctic species is a reminder that life is tough, that it finds ways to survive, and that even in the face of great challenges, there is reason for optimism. The North Pole is a place of quiet beauty. Beyond the science, the politics, and the challenges, the North Pole is simply beautiful. The ice glows in the low sunlight, the aurora dances across the sky, and the silence is deep and profound. It is a place that touches something in the human spirit, a sense of wonder and awe at the natural world. This beauty is not flashy or loud. It is subtle, found in the way light reflects off ice, in the delicate patterns of frost, in the distant call of a bird. It is a beauty that requires patience to appreciate, that reveals itself slowly to those who take the time to look. For many people, the Arctic represents a kind of purity, a place unspoiled by human development, where nature still reigns. This perception may be romantic, but it reflects a deep human need for wild places, for spaces where the natural world can be experienced on its own terms. The stillness of the Arctic invites reflection. The Arctic, with its vast spaces and profound silence, is a place that invites reflection. There is time to think, to ponder, to simply be. The pace of life slows, unburdened by the distractions and noise of modern existence. In the Arctic, there is space for contemplation, for considering one's place in the world, and for connecting with something larger than oneself. For researchers who spend months in the Arctic, this reflective quality is often mentioned as one of the most valuable aspects of their time there. The solitude and stillness allow for deep thinking, for creativity, and for insights that might not emerge in busier environments. The Arctic's stillness is a gift, one that is increasingly rare in a world that never seems to stop. It is a reminder to slow down, to listen, to observe, and to appreciate the quiet moments that life offers. And so, dear listener, our journey to the North Pole comes to a close. From the drifting ice and the frozen ocean beneath, to the dancing lights of the aurora and the resilient creatures that call the Arctic home, we have wandered through a landscape of ice and wonder, of silence and beauty, of change and endurance. We have felt the cold, seen the vastness, and glimpsed the delicate balance that defines the top of the world. The North Pole is a place of extremes, where the sun circles the horizon for months, where the temperature can plunge to depths that challenge survival, and where the ice is always moving, always changing. It is a place of life, from the tiniest plankton beneath the ice to the massive bowhead whales that swim through Arctic waters. It is a place of beauty, from the shimmering aurora to the deep blue of ancient glacial ice. But it is also a place in transition, a region transforming before our eyes as the planet warms. The ice is thinning, the permafrost is thawing, and the ecosystems that have thrived for millennia are facing unprecedented challenges. The North Pole reminds us that our planet is fragile, that the systems we depend on can be disrupted, and that we have both the power and the responsibility to protect what remains. As you lie here, letting your breath fall into a gentle rhythm, imagine yourself standing at the very top of the world. Picture the endless ice stretching in every direction, the cold air sharp and clean, and the sky above vast and clear. See the soft glow of the sun on the horizon, the stars beginning to emerge as twilight deepens. Feel the stillness, the profound quiet broken only by the distant crack of ice. The North Pole is both a place and an idea, a point on a map and a symbol of the wild, untouched places that still exist on our planet. It is a reminder of the beauty and the fragility of Earth, of the interconnectedness of all things, and of the responsibility we carry to protect the world for those who come after us. Just as the Arctic cycles between light and darkness, between ice and open water, we too move through cycles of waking and sleeping, of action and rest. The day gives way to night, and our thoughts drift toward dreams. If you are still awake, you can continue to the next video when you are ready. But if your eyes are heavy, let the quiet of the Arctic hold you. Let the stillness carry you gently into rest. Close your eyes, breathe deeply, and drift into sleep, into the soft embrace of the polar night, where the stars keep watch and the ice holds its ancient secrets. Good night.